Hello, everyone. A very good afternoon to all of you. I, on behalf of Rippling, would like to welcome you all for taking out the time and coming over here on the 80th edition of React Bangalore Meetup. To start with the event, we have our first speaker, Sagar, who is going to talk about how Xflow's front-end team boosted web performance with Next.js. So please give a huge round of applause for him.
Hello. Okay. Good afternoon, guys. My name is Sagar Preet, and I work at Xflow. So Xflow is a fintech startup, right? So it deals in the cross-border money movement space. So am I audible? Yes. Awesome. Okay. So one of the hero product that we own is the dashboard product. And on this dashboard, right, users can sign up and they can create invoices, they can share it with their overseas partners, and they can receive money internationally. So throughout this talk, right, which is about the web performance optimizations, I would be mostly taking example of the dashboard product. So we will be covering three problems today, and we will be seeing the solutions, the optimizations that we did, their user-facing impact, and the impact on the Web Vital. But before we go into the problem part, a little bit of backstory. So in 2021, right, when I joined Xflow, I was one of the few early engineers to join the startup. And at that point of time, there was no product, right? So we were not focused on the web optimization at all. But over the years, right, we launched so many products, features. Now we have like thousands of components and stuff, right? So what we noticed, right? Uh, okay, but in 2021, actually, right, one good thing we did, which I forgot, is we evaluated all the front-end frameworks which are out there. So we selected Next.js, the reason being because it comes with a lot of out-of-the-box optimizations. So for example, there is image optimization that is like based on your resolution, based on the width and height of your browser, the image component makes sure the image is rendered in an optimized way. Then there is some link prefetching in Next.js. That is, if any link is visible on the viewport, right? Next.js tries to download the JavaScript associated with that link so that when the user is actually trying to click that link, right, the UI is instantly loaded. So that is link prefetching. Then there is some font optimization which comes out of the box that makes sure the layout shift is minimal when the UI is loaded. So the crux is basically Next.js comes up with a lot of out of the box optimization. So it helped us to focus on building the product rather than focusing on the optimization. Something happened. Okay, cool. Yeah. So, but the inevitable happened. So in 2024, right, because we added so many features and stuff, our dashboard had degraded performance and the web vitals were actually very bad. Right. So basically, this was high time that we focused on the dashboard and its optimization. So this was basically our journey as to why we started on the performance part. Right. So let's now move on to the interesting part, which is the problem one that I want to cover today. So the problem one, right, is we noticed that the first load JavaScript for the dashboard became close to 3.84 MB, right? So what it means is that once a user opens dashboard.xflowpay.com, right, the HTML will be rendered. After that, it will try to download 3.84 MB of JavaScript, right? And not only that, once this JavaScript is downloaded, the browser tries to parse this JavaScript, right? So that hydration takes place. And once hydration happens, your UI becomes interactive. Now imagine there is a person who is on low in a bad internet connection. This downloading of 3.84 MB, right? It will take more time. And because the size is large, the parsing will take more time. And ultimately, hydration will take time. And ultimately, the time taken for your UI to become interactive will be more, right? So this was very important problem that we had to solve. Also, consequently, the LCP, which is the largest contentful paint, right? It was around 4.9 seconds. And according to Google, anything greater than 4 seconds is in the poor category, right? So before we go into solution, right, what is LCP? LCP is the largest contentful paint. So as a quick example, if you see this screenshot, right, from CNN.com, the LCP at time t equals to 0 was this text node because this is the largest node on the UI, right? After a few seconds or after a few milliseconds, this became the LCP. And finally, when this image is rendered, right, this large image, because this is taking more space on the UI, this becomes the LCP. Right. So in our case, this was 4.9 seconds. So we had to basically debug this, like what is going on. So let's focus on these two problems, the JS chunk and the LCP for now. So in order to debug this problem, right, what we did, right, as a developer, we were curious as to why this JS asset is taking 3.84 MB. So we opened the asset and we tried to understand. Of course, we cannot understand this because this is minified. So to make sense of this asset, right, JS asset, what we did, we integrated with Webpack Analyzer. So what is Webpack Analyzer? It is a open source tool where you can see what is taking space inside your JavaScript asset. So this is the output report of our common JS asset. So here, right, we analyzed this report and we found that there are three problems that we want to fix. So if you see these large rectangles, right, writingpad.tsx and pinksphere.tsx, right? So we opened these React components on in our code base, and we were kind of shocked because these React components, the content was nothing but set of SVGs, right? And these SVGs somehow are getting bundled into our common JS asset and increasing its overall size. So definitely the usage of SVG that we did was not optimal and we had to fix this. So this is subproblem one. Then second subproblem that we found was inside the node modules. So we analyzed the node modules and we categorized these packages inside node modules into two parts. So one is basically the packages which are needed in almost all the pages on dashboard. So example, there is framer motion. I'm not sure if you can see, but framer motion is somewhere here. Then this is row dash. So framer motion is basically a library that is used for the animation. And Rodash is another amazing library that is used for it's a JS utility library which helps for object manipulation and whatnot, right? So these libraries are used in almost all the pages. So we wanted to keep these packages inside the common JS chunk only. But what we were not okay was how much space they are taking inside the asset. So this was the subproblem 2 that we analyzed. Then finally, the subproblem 3 from this report is, if you see libraries like pdf.js, right, they are taking good amount of space. But these libraries are used in few pages in dashboard. So for example, we have an invoicing tool on dashboard where freelancers and sole props, they can come and they can create fancy invoices and they can preview PDF and stuff, right? So this library is used only in few pages. So what we wanted was we wanted to remove these libraries from the JS asset, right? So yeah, so let's try to see the solution for each sub problem, right? So this is the first issue was the SVG issue, right? So SVGs are awesome, right? Because they always make sure, depending upon the width and height of your browser, SVGs always make sure the image quality is top notch, right? So, and mostly how, in most front-end teams, what happens is there is a designer who gives link to the Figma. We download the SVGs from there, copy paste into our code base, and we convert a React component out of that SVG, right? Now, the thing is, what we have done is we have converted SVG to JSX, right? Because this is a React component. And what will Webpack, which is the bundler, do for us is convert this JSX into JavaScript, right? So ultimately, what we have done is converted SVG to JavaScript. But the question is SVG a JavaScript? No, right? SVG is an image. So when we convert it into JavaScript, it is getting bundled into the common JS asset and increasing the overall size. So what we wanted to do was we wanted to remove this SVG. So just to show you a quick demo, right? So this is a table where SVGs are used as React component. So if you see the content of this SVG, right, it's visible. So in our case, this content was inside this common JS asset, right? So just to show you, if you search for create element SVG, right, you can see there are 34 occurrences of these SVGs, right? So these SVGs were part of our common JS asset. So in order to solve this, right, what we did is we are now using old way of using SVG, which is to use it as a sprite. So as an example, so if you see this table, right? So the content is not here in this SVG because this SVG is using the native use HTML tag, which references to a sprite, and we have given an ID. So what is a sprite, right? So just to show you a demo sprite. So this is a sprite. You can think of sprite as a hash map where you basically you have set of SVGs and each SVG has an ID. So once you give an ID, it spits out the SVG. And this sprite, right, what we do is we preload this sprite on the mount of the HTML and we cache it on the user's browser. So that, and why we are okay with caching it is because SVGs are something which don't change frequently. These are like icons or illustrations, right? So we cache it on the browser. So in this way, right, by using SVGs as a sprite, we were able to remove those SVGs content from this JS asset, and ultimately we reduced the size of the JS asset. So this was the subproblem one solution, right? SVGs are taking space. Then second subproblem that I want to focus is that some node modules like Framer Motion and Rodash, right? We want these libraries to be part of the common JS asset, but we wanted to reduce their size. So what we did, we basically found that we analyzed these libraries, and few example that I want to take is Framer Motion. So we used motion component from the Framer Motion in most of our website, right? What we found is there is a slimmer version of motion, which is the M component. So M component has less size and it doesn't have few features. For example, if you want gesture control or if you want layout animations that are missing, but still for 80 to 90% of the use cases, this M component was enough for us. Then second thing that we did is Rodash. So mostly I think how we use Rodash is like this, right? So the problem with this syntax is that this is not tree shakeable. Right. So what is tree shakeable is like if you are using two functions out of the 20 functions available from this library, still those 18 functions are bundled into your JS asset. So what we found is that instead of using like this, if we use that specific function, rodash slash is equal, so the size is actually reduced. To quickly show you a demo, right? So if you see, so there is an extension I've added for VS Code, which tells us the size each library takes. So if you see motion component, it takes 108 KB. But if you use the M component, it takes only 15 KB. And you can see the gzip size also in the brackets. Similarly, for the Rodash, if you see, it is taking 71 KB, but if you use that specific function, it is taking only 16 KB. And then you can see the gzip size also, that is also less. So basically, that's how we make sure that these libraries is in our common JS chunk, but they are taking less space, right? Then the third sub problem is that some node modules we wanted to remove from the common JS chunk. So for this, what we are doing is we are dynamically importing those libraries. So as an example, this is the component which is internally using React PDF, the pdf.js, right? So we are dynamically importing that. So what happens is when this component is rendered on the UI, on demand, we will try to download the JS, right, associated with this component. And till the time JS is getting downloaded, we show this fallback UI. So ultimately, by using this syntax, right, dynamic import, we chucked out those libraries from the common JS asset. Cool. So basically, by doing these three optimization, right? And if you see the implementations were pretty straightforward. The first May, what we did, we basically used Sprite instead of SVG. Second optimization, we used slimmer versions of the libraries. And third optimization is now we are using dynamic import for certain libraries. So the result was that we noticed, right, the common JS chunk from 3.84 MB, it is only 760 KB. And second thing we noticed by doing this optimization is the LCP reduced from 4.9 seconds to 2.6 seconds. So yeah, so this was basically the optimizations that we did to solve the problem number one. Let's move on to the second problem that I want to cover. So the second problem is that we noticed that for the dashboard Next.js application, right, the Docker image size became close to 600 MB. And if you see, it was 672 MB to be precise, right? So now you would be thinking like why this Docker image is impacting the Web Vital, or how are they impacting, how this is impacting the users, right? So the answer is no, this has no implication on the Web Vital, but for us, this had an implication on the users. So why? Because what does so mostly like what happens is, let's say there is a bug in the production, right? And as a encore or as a developer, I want to instantly fix that bug, right? I want to do a hot fix basically. Now what used to happen is, because the image size is 672 MB, our CI pipeline was taking around 15 minutes, because it has to make this 672 MB of image, right? And second thing was the deployment. Now, let's say we have, I think, 20 pods. Each pod takes, will try to download this 672 MB of image. So overall, this CI/CD used to take 22 to 25 minutes for us, right? Which is a lot, because during those 25 minutes, our users will be facing errors, and we will be getting alerts and escalations, right? So this became very important problem for us. And in order to solve this problem, right, and as a part of this problem, we wanted to minimize the blast radius, and we wanted to minimize the time taken to deploy. So the solution, right? Uh, so we found that in our Docker image, node modules were the ones which was taking the largest space. Uh, because as part of the Docker file, there was one step where we were blindly copying the node modules into the final image. Right. So why we do that, right? Because as a developer, I don't know which modules are needed during the build time, and which modules are needed during the runtime. So what we were doing, we were blindly copying all the node modules into the final image, right? So this was not a optimal way. And we found out that in Next.js, starting from Next.js 12, right, they support a standalone mode. So in your next config, if you give output as standalone, right, what Next.js will do, it will spit out a standalone folder, which will only contain the files which are necessary for your runtime of your application. So how it works is, basically Next.js uses a library which is known as NFT. So this NFT is created by Versa people only. So what NFT does is it basically scans your components and your pages and even your node modules, and it tries to copy only those files which are necessary for the runtime of your application. And also, while preparing this presentation, right, I found that this NFT library even goes inside each package of node module. And inside each package, right, let's say what library maintainers do is they put testing folder, source folder, and bunch of random things. NFT will make sure even those files are removed during the final build. So this was pretty awesome that we found. And as a result, right, what we noticed that the Docker image size from 672 MB, it is now only 144 MB. And consequently, our when we have to do hotfix, right, we are able to do that in under 10 minutes as compared to 25-30 minutes that used to happen. Okay. So now the final problem that I want to cover today is the FCP. Right. So FCP is the first contentful paint, and it was around 2.2 seconds. And according to Google, anything greater than 1.8 seconds comes in the needs improvement category. Also, FCP is not a core web writer, right? It's not considered as the core web writer, but it is very important for us because it has a user facing impact. To show you, right, why FCP has a user facing impact. Uh, Okay, so by the way, what is FCP, right? FCP is basically the time taken when you enter, let's say, any website, example.com, the time taken to render any visible node. So that node can be a text, SVG, video, anything. The time taken to render that from your document load is known as the FCP. So I have a demo for this. So let's say the user comes to the dashboard and they click enter. So they will see something is getting loaded. And after a few seconds, the HTML comes, right? To show you again, the user comes, open the website. We are showing something is getting loaded, and then the website come. So what the user will think is that either our website is slow or their internet connection is slow or something like that, right? So it's not a good user experience. So just to show the React code, uh, you know, what used to happen in dashboard was, so this is the React code. Right. So this is a minimal reproduction where we have the dashboard HTML that we want to render. But before that, we are executing some server side logic. So in dashboard, what happens is like once someone comes to the dashboard, right, we check if the session cookie is valid or not. If the session cookie is valid, we basically render the HTML and give back to the client. Otherwise, we redirect to the login page. So all this heavy lifting, right, happens on the server, and it involves firing of APIs, database transaction, and whatnot. So that's why this server side logic takes time for the dashboard. And once this authentication happens, right, we pass this data back to the HTML, to the page. Then Next.js render this HTML on the server and it gives back to the client. So that is what was happening in this demo, right? So we wanted to fix this because it had a user facing impact. So in order to fix this, we are now actually using server components with suspense and streaming. Right. So is this image clear to everyone? And you are able to see this image? Okay. Okay. This is the best I think that can happen. Okay. Cool. So basically, right, in order for me to explain why server components decrease the FCP, right, and uh, like basically it improves the FCP web vital, what I want to first explain is the traditional way of rendering, right? So traditionally there were CSR and SSR, right, client-side rendering and server-side rendering. So what used to happen in client-side rendering, right? So imagine this is the user. The user opens example.com, request goes to the server returns the HTML instantly. Now in the HTML, right, using CSS or something, you guys are able to see. Cool. So using HTML, right, using CSS, we are instantly showing the loader. And at the same time, the JavaScript will be downloaded, hydration will take place. And after that, let's say some component fires API 1. So we will fire API 1, and after that, we will fire API 2. And then finally, the UI is completed, right? So here, if you see, this zigzag is happening, right? What is this zigzag? This is basically the network time, right? But there is one advantage here with CSR, which is that we are instantly showing the loader on the when the HTML is returned. So that is basically the advantage of CSR. Then let's move on to the SSR, server side rendering. So this is what is the demo that I showed you, right? This is what is happening on dashboard, what's happening on dashboard. So there is a user opens example.com. The request goes to the server. On the server, then we fire the API 1 and API 2. Once we get the data from these API, we render the HTML on the server only, and then return the fully loaded HTML back to the client. Now here, if you see, right, what is the advantage? The advantage is the network time. The zigzag is less, right? And why zigzag is less? If you see this, right, mostly front end and back end are in the same region, right? In our case, it's AWS Mumbai, and they communicate via the Amazon network, right? So it's super fast. So that's why this zigzag is less here. Uh, but there is a disadvantage, which is we don't show any loader. In CSR, we were showing this loader instantly, right? So this is the disadvantage here. Now, uh, what we wanted was we wanted best of both world. We wanted instant loader also, but at the same time, we wanted less network time. So that's why we found that server components with suspense and streaming is helping us. So as an example, this is the user opens example.com, request goes to the server instantly returns the HTML back to the client. Now in the client using CSS, we are showing the loader, but on the server, right, in the background asynchronously, the server is firing API 1 and API 2. And once these APIs are succeeded, right, on the server, it will render the HTML that I want to show to the user. And then this HTML is streamed back to the client using the same network core, right? And then the UI is completed. So the advantage is the we were able to show the loader instantly. In the background, server was doing some magic of firing the API and then rendering the HTML. And third advantage is using the same network core, we were able to stream the HTML back to the client. So as a demo, right, to make it more uh, clear. Okay. So if I open dashboard, right, we are showing a loader instantly. And then after a few seconds, the HTML JSON is streamed back as part of the same network core. So if you see this network tab here, right, I will refresh the page. It took only 34 milliseconds for the loader to come. And after 4 seconds, as part of same network core, the HTML is given back to the client. And also let's notice the size also. So it took only 554 bytes, and after that the remaining 4.8 KB of HTML was given to the client. So basically using server components, right, we were able to achieve best of both world. And as a result, right, The FCP from 2.2 seconds is now only 100 milliseconds for the dashboard, right? So this was basically the third problem that we fixed as part of this journey. There were a couple of other fixes that we did, but as we can cover that maybe in next talk. And this was my first talk, so that's why I wanted to keep it limited, and so that so that I can explain them better, right? So basically, the conclusion is that web performance, right? It should be an ongoing activity in your team. It shouldn't be like you wake up one day and you say that, okay, today I have to optimize. Or maybe you wake up one day and you see that, okay, the dashboard or your website is performing in a degraded experience. So it should be an ever ongoing activity. And there are three guardrails that I want to propose. So one is, so why these are needed is because you don't fall back to the degraded experience. So one thing you guys can do is we can integrate this GitHub CI action. So what it does is whenever someone raises a PR in your team, right, you can use this GitHub action to run your code base in a local container where we can generate, where this action will generate a lighthouse score for you. And also if there are any bad practices implemented as part of your code base, right, it will basically tell you that, okay, these are things and you can fade the PR. So this is one thing. Second is we can actually integrate with observability platforms like New Relic. So what these platforms do, right? These platforms basically tell us how your website is performing in the wild. So for example, let's say you have a product, right, which is used by so many people in different geographic region. They will be using different browsers. They will be on different internet connection. So these platforms will basically tell you the web vital score for these users which are using your website in the wild, right? And a bonus point can be you can actually create alarms on top of this. So as an example, if your some SEO score is dipping, let's say on an average of 2 weeks using New Relic, you can actually get to know that, and you can build alarms on top of that. Then finally, the third and the most important point is to think before using an external library. See if the library, if the package is tree shakeable or not. Check if there is a better alternative available. And yeah, pretty much that's it from my side. And thank you guys for listening so patiently. And thank you. For questions, any questions or anything? Yeah. Hi.
Doctor image problem. Uh, I understand that initially there is side of 700 MB plus, and then you made the change of standalone listing and node underscore module got reduced. Size of the node underscore module, typically node underscore module folder holds all your npm dependencies, right? So what is the dependency which is at the runtime? Because if you build your React project itself, all dependency has to be there at the compile time, right?
Yes.
But what is there? It's the runtime. Something.
Understood. So if you see, right, we have server-side logic in Next.js, right? So some libraries are needed. For example, we have a gRPC client. So what we do is we establish the connection with the backend from the Next.js server to the backend. So for this, there is a dependency gRPC JS that needs to be there during the runtime. Similarly, the Next itself needs to be there installed. So there are a couple of such libraries that are needed during the runtime. So if you use the standalone mode, right, and if you build, so you will see that in the node modules, it will not be empty. There will be a couple of libraries which are actually needed during the runtime. Hmm. It depends, right? Like, do you have any, like, are you doing any server side rendering? So basically, some modules are bundled in your JS asset, which the client uses, right? But there are some modules which are not bundled also. These are needed during the runtime. For example, if you want to do some database connection establishment, right? Maybe it's using some SQL client. So these will not be bundled into your JavaScript asset. These are needed during your server runtime. A.
Yeah.
Hello. 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 Yeah. So you give an example of server-side rendering with streaming, right? So I have a couple of questions on that because it becomes increasing complex. A, to handle caching there, B, to handle SEO there, and also you have to handle errors very gracefully because you are streaming content and So how do you handle these? Because it offers numerous benefits because we also use streaming with some rendering, but it also comes with the challenges.
Correct.
Yeah.
So I think there is very good documentation from Next.js, which basically tells that server components don't affect the SEO. Right. So I will try to find that, but what happens is server components don't affect the SEO. If you see, right, in dashboard also, we not dashboard, but we have a website product also. We are using server components there, and anytime we do any change, right, the Google crawls that content and it shows the latest thing on the when we search for our website. So SEO is actually not affected as such. For example, this is our website. And what was your second question?
Oh, yeah. So first was the SEO. Second was the error handling. How would you handle gracefully errors? Because you can't just move back user to suspense or some other things, right? And third question is how do you handle caching in some situations? Because you have multiple APIs being run, streaming over.
Understood. So, okay, let's break the problem. So first thing was how do we handle the errors, right? So like the error can happen on the server, it can happen on the client, right? So if you are talking about server components, right? So suspense is there, and then we can wrap that suspense with the error component, right? So basically, when your UI is suspended and we are showing a fallback UI on the server, we can gracefully handle uh, for example, Next.js, I have this loading.tsx, which was showing that loader. You can add error.tsx. So your suspense, basically what is suspense? It's a promise, right? At the end of the day, if it gets rejected, you can catch it and you can handle gracefully. So how we can handle gracefully is you can have a retry mechanism, right? If, for example, you are not able to reach the backend as part of that async call, you can retry it. Otherwise, of course, you can always show a error UI to the users. So on the server side, this is the handling. And yeah. And then the third portion is caching, right? So Next.js has a lot of caching layers. And you are correct, it is very difficult to understand in the first go because caching happens in multiple layers. Like if there are multiple API calls that are fired from different server components, it will try to kind of like make sure only one call goes to your backend, even if multiple calls. Then there is caching. If you use the fetch API call, then there is caching. So yes, it's a multiple layer of caching. And as a developer in our team also, it was very difficult to understand and implement this. But I think over time, it is now kind of because we talk about these things in our team very regularly, like what are the good practices and stuff. So now I think all the developers are kind of comfortable and we are able to use server components.
Yeah, cool. Because we tried using this, and there are still Next.js has open issues on GitHub regarding server components, caching, and all these mechanisms. Like recently, they also changed the caching mechanism of fetch API calls, right? They're no longer
They
cached
have
by
disabled
default.
it.
Yeah, yeah. The second last question, I'll not take much time. Do you use Vercel as a deployment provider?
No, we use AWS, but for the website that I showed you, the user-facing website, right? This is deployed on Vercel, but the dashboard product is deployed on AWS.
Okay, because the things that you show, Vercel, because we use Vercel as an enterprise customer. So all of those things that you show, uh, Vercel does it for us, like all the bundling of things. And so our build time takes around 3-4 minutes because it's handled caching so easily. Yeah.
Understood.
I think if you use Vercel as deployment, you won't have to do all of this stuff again and again.
Yeah, I wish it was easy to use Vercel because like our entire backend is deployed on AWS and we have VPC, VPN and all those companies constructs, and it's very difficult to join the Vercel VPC to the AWS VPC. I think they have some enterprise thing, but we don't want to pay that much right now. So yeah, that's the.
Oh, thank you so much.
I think. Thank you guys.
We'll take the next questions in the break. Feel free to catch him. Thank you so much. Please give a huge round of applause for him. So coming to the next speaker, how many of you have played Dream 11? I think everyone must have at least heard the name. at least maybe in the messages, the spam messages which they send, or like while actually playing the games. So now we have Mayank from Dream 11, who is going to talk about how they scale the performance in their mobile applications.
Hello. Hey everyone. Good afternoon. Uh, so, as Shweta introduced me, my name is Mayank. I'm the director of engineering at Dream 11, part of the platform team responsible for mobile applications performance and open source. So, yeah. So before we begin, right? As you have, how many of you have played actually Dream 11 on the mobile application? A lot of you, I can see, right? So can you tell me whether the mobile application of Dream 11 is on React Native or the Android Native or iOS? It's on React Native, right? So, but it was not always the story. So we started with the native development. So we were in Android as well as iOS. Sorry, my throat is a little acting up. So please be mindful of my voice. We were not always on the React Native. So we were on the Android application as well as the iOS application. And we had a good run, but then there was hiring problems. There are a lot of functional issues, basically the ecosystem of all the developers. And when we want to hire, we have to uh, find different problems, and then we have to build the same thing twice. And there is always a battle between the iOS folks and the Android folks that we can design this, but you cannot design, and all of that that goes around with it. So we decided to move to React Native, but with React Native came one major challenge: the performance of the application. Our users, we have around 230 million users registered on our platform, and with that comes a lot of devices. And a lot of those users also are on very low end of the spectrum of the mobile device, right? So React Native performance became a major problem, and that's when my team was constructed from ground up. So we collected few passionate folks from the whole Dream 11, and we created the mobile platform and performance team. Okay, so today we are going to talk about how we matched our performance of the native application with the React Native application, right? So what do we usually mean by performance? So performance is a measure of how well your users are able to use the application, right? But more or less, when I hear from people and talk to a lot of folks, they said, if my crashes are good, my app is performing very well. If my ANRs are good or everything on my Play Store is good, my app is performing very well. And then there is one product manager that comes to you and say, मजा नहीं आ रहा है, ऐप थोड़ी सी स्लो चल रही है यार. भाई व्हाट इज स्लो? मतलब स्लो क्या होता है भाई? कि भाई सीधा स्लो चल रही है, मजा नहीं आ रहा है. So then we introduce again. So ये जो slow वाली problem है, right? अब so today we'll try to get some data around how we can understand and attribute what slowness is in an application, and how we can see how we do it on the pre-production as well as post-production data. But again, a lot, as Sagar mentioned in the last slide, right? You can use New Relic or Firebase and a lot of such tools to do observability. But and crashes and ANR have like out of the box support for stack trace. You have profilers to debug CPU, memory, and network usage. And then this again, the slow problem comes. Yeah. So before we move into the application slowness or performance, we need to understand how the user is behaving or interacting with the application. Correct. So when a user interacts with the application with some actions, he perform minor actions. He either clicks on a card or wait for a page to load and all of that. And what happens in the background when these actions are happening? There is some CPU and memory usage going on. There is some network usage going on, and all of that uh, hardware usage that we are do, and the mobile resources that we are using. And one more critical thing that we do is event telemetry generation. So all of us have events, business events that we put in the application, and we track how the business funnels are going and all of that. So there's a stream of event also generating in the background. Now we'll see how we can utilize these events to come up with how slow our application is. Right. So what we'll cover, we will cover and define what are interactions in the application, how we measure those performance, and what are the challenges that comes with scale. Right. But before we move forward, uh, how many of you are here backend developers, right? So when I say scale, the backend developers are like cool, भाई हमारे पास scale है, हम इतना सब handle करते हैं. I have such a RPM and all of that. But what do we actually mean by scale in the mobile application? Mobile application has only one user at a time, okay, and that's it. And that's the only scale that that particular device has to handle, and that's the only application that the device has to run at that time, right? You don't have to care about any other application at that time. मेरी app चल जाए, I am fine. ठीक है? But what do we actually mean by scale in a mobile development world, in the React Native world? Yeah. Correct. So one of the parameter of scale is features. So there are a lot of features in my application, and we are we are very skilled, right? So, but what else? What does scale bring to the table? Correct. But that's a if I be narrow-minded, but my team is going to hate me for this because it's my responsibility to handle certain backend folks as well. So I don't care. The mobile is going to hit as many as it wants. That scale is the backend's problem, not the mobile's problem, right? So the scale brings the variety of devices, the variety of screen sizes, and the variety of how users are interacting with the application, right? So this is what we usually mean by scale in the mobile application development world, and that's where we are going to focus our problem solving for purpose of scale. Now let's understand interactions. So interactions are like, some of you must be thinking like it's very obvious. It's a small meaningful step from point A to point B. But trust me, it took us some time to nail down this definition, because when you start defining something, you start building a product on the core of that definition. So small meaningful steps from point A to point B, as you can see, is a screenshot of our application. A user has clicked on the match card and has landed on the contest homepage. Now, the success of this particular interaction can tell me whether my application is performing good or bad, correct? So how the better the success of this particular interaction, I can tell okay, this is performant. Agree? Okay, but how do you actually measure the success? What is success? There has to be some data, na? It cannot be a notional value. It's not something I am saying it is going good. You are saying it is bad. Now we'll fight with each other until unless we break anyone's head and go home. But when we have data into that mix, we have an arbitrary methodology as well as somebody who can break the tie between us. So let's introduce some data. So how do you usually measure the interaction of a success? Success of an interaction, fumbled up. So we can define it in the three ways: how fast the interaction took place, was the interaction complete itself or not, or how smooth the interaction was, right? And we were generating the event telemetry data. So let's say I trigger an event T0 at the start of my interaction and T1 at the end of my interaction. If I'm able to get T1 minus T0, I can tell you how fast the interaction is. And if I get the ratio of T1 by T0, I can tell you what was the success rate of my application. And what was the frame rate of the application during that T0 and T1, right? So that will give me how smooth the interaction was. So based on these three parameters, now you have a metric you can talk about when you say, okay, my interactions are going good or bad, right? Now let's see how we collect this data, measure this data, and understand this data, right? So for that, we need to come up with a framework. And the framework needs to be agnostic. It cannot be, it just work on the iOS device or the Android ecosystem, or maybe let's say if I want to use it for the web itself. So the framework has to be agnostic of the versions that it is working on. Okay, so the same framework should work on iOS, the same framework should work on Android, and same work for web if you want to use our web itself, right? And it should be agnostic of teams. The same framework that I am using for my team should be applicable for your team as well. Otherwise, we'll still have battle. I don't know. I don't believe your judgment. I don't believe your data. So we need to come up with a framework agnostic of team as well as platforms. And the framework needs to cover the whole cycle of any analysis, any mathematical analysis, right? So for any analysis, you need to first generate the data, right? The second is you need to measure and then analyze, deduce some result out of that analysis, and take some action to complete the whole cycle of any framework. So this is what we built. Now let's see how we tackle the problem of generating a data. Okay, how many of you here are goes gaga and love it when the product manager comes and says put these 10 events in the application? No one, right? I personally hate it because they come at the end and then they want a parameter in the event, and it's like now I have to pass it from previously five screens, and I'm like, I'm done, I can't do this. So but again, we need event for this analysis, correct? So what we took this inspiration that events are the atoms of our analysis. And if we have certain finite categories, okay, so the user actions are also finite, right? Either it's a press, it's a navigation, or an API call, or page load, right? There are some finite categories that you can divide those events into. If I can create those events, generic events in the application, inject at the central level, in the component level itself, okay, and uniquely identify that particular event. Okay, for example, if press is being clicked on this particular button or that particular button, if I am able to uniquely identify this or that, my developer doesn't have to add it, right? So zero dev effort, agree? So we introduced this framework that, okay, let's build it. We call it event taxonomy. We created a framework around it, and we did bucketization of events into finite one: press, navigation, page load, API success, API load actually. I don't remember the correct name of it. Yeah. And we empowered it to track any interaction in the application. So a press of this and a page load of that, right? A pull to refresh, basically action 1 to action 2. So it gave me infinite opportunities. But this infinite opportunity also gave me one more problem: infinite data. Okay. So just to give you a perspective, during IPL peak, IPL this year, can anybody guess how many users were interacting with our application in 1 single minute? Correct. So our user concurrency was 15 million. 15 million users were interacting with our application in 1 minute from 7 p.m. to 7:30 p.m. during the IPL final. Okay. Now, guess each particular application instance is generating at least 500 to 10 thousands of events. Multiply it by 15 million. And the backend folks are like, I'll kill you next time if you send so many data. Right? So we needed a fine-grained control mechanism as well. So we built a whole ingrained fine-grained control mechanism on top of that layer that tells you exactly which particular event you want at any particular point of time. So I can control it remotely. I can just type a configuration on my dashboard. I can send it. It will be available within 10 seconds to the mobile application, and it will start generating that data. It doesn't generate all the data at all the time. It generates some data that you want for your analysis. Otherwise, it will kill the user's phone as well, right? It will create a lot of APIs. There will be batching and all of that. There will be battery consumption. User will still complain. Your app is taking so much data and all of that. इतना तो पैसा नहीं जीत रहा हूँ मैं जितना तो मेरा data खा जा रहे हो. But yeah, we do have a lot of crores. So yes. So now we have the data. We have generated the data. The second part is measuring and analysis. The measuring and analysis, as well as the data characteristics, change in pre-production as well as post-production. Correct? So what are the characteristics of a pre-production framework? We have finite data, right? Hardly how many of us test our application? Everybody do, but I know कि ठीक है चलता है. So basically you have finite sessions, finite data. You have controlled environment. How many devices or variety the company can give you? It can give you 10 devices, 20 devices, or maybe if you are part of Weber's team, they can give you emulator as a service. You can spawn anything, but still happens finite data. measurement and analysis. So now I have generated the data, I have finite data and all, but the finite data poses a problem. How do I ensure that the data is correct? Right? Because I can do 100 iteration or maybe 200 iteration at max as I want manually if I want, or if I want to generate it via pipeline, but 200 at max, but the deviation can be there. So we need to define certain error rates and standard deviation. What is the error rate in that data and what was the standard deviation in the data? So we ensure that the mean in the data is correct. And the third, the analysis part is you need to compare that mean against a certain threshold, right? And what results in action? So if the particular threshold has been breached, you need to take an action, and the action is usually to, the fancy word of saying is, tumne phada hai, is attribution. You need to attribute it to some team that, okay, this particular commit or this particular team may have increased the timeline is this particular interaction. So next we'll look at a pipeline of how this particular system works for us. So a developer, whenever he pushes a commit or at the choice of his time, he builds an application. He selects a runtime environment. Now the runtime environment also differs, right? As I told you, there are a lot of devices that we cover. So one device can be OnePlus, maybe Node, or maybe S24 Ultra, and then one can be Vivo Y16, I guess. So, but how my application is behaving on a S24 Ultra is not exactly same as it is behaving on Vivo Y16, right? So it requires certain runtimes to work on. So this particular part of the pipeline enables you to select the runtime you want to run on. Okay, so it has a lot of devices attached. So we have our own OpenSTF system, which have like a lot of devices connected to a server farm, and we let the developers select a device they want to run this particular iteration on, and then they choose an iteration. Usually the default iteration we set at 100, but sometimes developer go crazy to 400, 500 as well. We usually recommend not to go them beyond 500 because the device starts heating and the performance degrades as well. The CPU also fatigues, right? So you don't get accurate data. So by the 500 iteration annual, we start calculating the standard deviation and the mean rate of it, error rate. If the error rate is less than 5% and the standard deviation is also within the acceptable limit, we say, okay, your data is correct. Else, the machine runs the whole loop itself. Okay. Why? Okay, so the whole pipeline is run again automatically. The developer doesn't need to intervene until and unless the error rate comes down to less than 5%. Okay, then that goes into the analysis phase. So the every particular feature or the every analysis pipeline that we have established has a baseline. For example, let's assume the startup time to be 4 seconds. Google says, if your startup time is more than 5 seconds, it's bad. Let's assume we keep the baseline at 4 seconds. So if any particular commit has increased the startup time by 4 seconds, it's bad. But how much increase? We need the threshold for that particular runtime as well, because the threshold for S24 Ultra as well as the Vivo Y16 needs to be different because the baseline are different, the mean are different, the error rate are different. So for a particular runtime, the baseline as well as the threshold is fetched from the system. And if the threshold is breached, we raise an alert immediately on the Slack channel. Okay, these particular commit IDs have been identified to increase the startup time by XX millisecond. Please take an immediate action. And what usually happens is, Robert is also the director of release there, and he just blocks it. It's not going there. चाहे अब भगवान आ जाए यहाँ पे, ये release नहीं जाएगी, because we take performance very, very, very seriously in our company. But okay, fine. Now Weber has agreed. We pleaded him, please let it go. And he sent the release with the threshold command on. But what is happening in the production? By the way, this is how the data usually looks when the data output is generated. That, you can see the standard deviation is 0.03, the mean is 0.409. This is for some random interaction I have taken. Above. Let's move to next. And yeah, one more massive thing, right? So before we move to production data, what it gives me advantage of is that it provides me a release on release analysis of how my flow are behaving, right? If somebody, as Sagar mentioned, right, it's an ever going activity, not random. Someday somebody going to come to me and say, your startup time has increased or you all of that. I can tell you how this startup time has increased, which release did this, and if the developer, however lazy he wants to go and check that timeline, he can specifically tell me, okay, from this commit onwards, this startup time or this particular interaction was behaving erratically. And this is where we are seeing the upward graph. Okay. Uh, Now let's move to the production analysis system. Now, as we discussed earlier, right, for scale, it's variety of devices. So that generates massive amount of data, just during IPL, during a normal day itself, right? And we have uncontrolled environment. There are 18,000 odd devices that Android OS supports right now. Okay. And I think this data can be verified by Play Store. And there are hardly, I think, every iPhone something is coming daily. So we have to support them as well. Uh, and the so we now have massive amount of data. We don't have the control on the environment. So can we run the same pipeline on production? We cannot actually, because I cannot store 18,000 thresholds as well as the baselines. No, I have control over the dashboard, but the analysis needs to make some sense as well. So the reason why that particular pipeline was working, because we had finite amount of data and finite characteristics of devices, correct? So we have the baseline for each particular flow. Now, assuming you have thousands of interaction in the application, you have stored thousands of baselines and thousands of threshold, right? And that multiply that by number of devices that are going in the production. That is going to be a crazy system, and that's not going to give us some meaningful insight as well. So in production, we don't usually go by the threshold breach as such or standard deviation and error rate. We usually go by P95, P50, P90 or P50. I think most of you have heard these terms. And the results and action are usually taken over a change of trend in a given time. So how much, if that basically the performance had degraded over 5 seconds or 10 seconds, it's not like it degraded for this particular interaction, right? And whenever that happens, it's not blame, it's an incident is created in the Dream11 ecosystem. So let's look at the production pipeline, as I mentioned. So the app is generating a lot of data. There's a proxy service that is receiving those events at a very high frequency. The sampling as well as the authentication is being taken at the proxy layer itself. So if somebody, I told you about that configuration, right? If somebody went crazy and he was like, "Ki, sub bhej do." So what will happen? Somebody has to be responsible for this proxy, right? So it also has rate limiters as well as sampling mechanism inbuilt so that nobody goes crazy. And I'll tell you an anecdote how crazy when we say crazy. How many of you here use Firebase remote config? Just one person. Okay. How many of you have thought that your application can take down Firebase remote config during a particular time event? We did that during our IPL 2022, I guess. During the first match of our IPL season, the remote config went down. Google said we cannot support this scale. Please lower your requests. We cannot do this. So that happened multiple times, by the way, not just with Google, with some other companies as well. So at scale, things break. So that's why we need those kind of protection there, like Google did, right? They just stopped giving us response and all of that. Now this proxy service transmits the data to the Kafka streams. So the Kafka stream has a lot of events going on. So there are different topics for each events and buckets. We'll go into detail if you have any doubt, but we'll skip for now. Then these event streams are moved to Flink processor. So we have our internal tool we call Streamverse that has a provision that where you can run your jobs, right? The queries in Flink. We are building support to write in JavaScript as well. So you start writing a query on Flink and it start processing the data in the uptime data storage. Okay. And that Uptime data is then fed into the alert engine as well as the visual dashboard. So visual dashboard is for somebody who wants to see it, and the alert engine for the whole incident mechanism. Correct? So this is usually how the data looks on some part of the dashboard looks like this. So basically it tells me P5, P50, P75, P90 and P95 in the real time. And the real time, I mean the moment it hits the service basically proxy, because I don't have control over the user's network, right? The moment it hits the user service, so the data it's available here, it's less than 5 seconds. In the less than 5 seconds, I can tell what is the P95 of my app version 5.28 for Vodafone in Mumbai. I can tell in 5 seconds how it's going. But why this 5 second matters to us? Why this time sensitivity matters to us? For our business to happen, we have only a window of 7 to 7:30. When the lineups are announced in the IPL, everybody goes crazy. And if there is slightly dip in performance of one particular interaction, or some XYZ microservice went down and it took down some interaction, we need to know immediately. And we need to create an incident immediately, and the resolution has to be fast. So the MTTD and MTTR needs to be very, very low for business like us, right? What it does is it provides a filter on low cardinality values I mentioned, the platform, app version, network provider, state as well as OS version. What it does, it runs an anomaly detection mechanism in the background, detects whether any particular permutation of these are behaving erratically as their usual trend line. And if it's happening, it creates an incident immediately. It notifies all the on-call person that are in the system, and everybody is sitting together. Okay. And this is how an incident looks. You see, this is how this output is visualized on the graph. Here you see this is divided into 6 parts. Okay. So this super green users are the people who are having the best experience of their life. Okay. They're winning, but best experience from a tech perspective. So these interactions are taking less than 600 milliseconds to complete. Basically the network call and everything. This is one of the example of a network call interaction. So this is the people who are taking less than 600 milliseconds to execute. And these are the people who are taking more than, anybody can guess? More than 1 or 2 seconds. 2000 milliseconds to complete. So this was going hunky-dory, everything was fine. Suddenly, the T1 event stopped coming. Why? Some of the random service in the backend went down. The Datadog alert was being raised and everything. What we attributed, okay, something went wrong, and we knew which exact flow in the application are affected right now. And this is how an incident was created. And then when the incident was recovered, everything went back to normal.
Caught by using your backend Datadog and stuff like that. But let's say if something happens with Geo or Airtel, if that goes down, then also this will be a problem.
I think. Yeah. So ask yourself this question. So suddenly, if your app stops working for Geo in Kashmir, how many of your current systems can tell you that? Ask yourself this question. You have a lot of systems. You are from very, very reputed organization that spends millions of dollars on observability system day in, day out. Ask yourself this question. If one page of my application stops working in Kashmir for Geo network, how would I know? And how much time it will take for me to know? Obviously, some user is going to complain, but that's a very high one. This system told us within I think 1 minute, because it also analyzed the pattern, that Dream11 has stopped working for Geo users in Kashmir, and like we sold it to everyone. Yeah, our system works. Because I know a lot of you have questions. Okay, I can do this via New Relic, I can do this via Firebase, I have spans, all of that. We get all those questions. We understand. But I ask you a counter question. Does that mechanism tells you the question I asked you? It doesn't. That's why the system is there in place. This. Okay. Let's take a phone poll. What's the average time in your organization to recover an incident? Any guess? Anyone? How much average time does it take in Dream 11 to recover an incident? Sorry? No, we are not Superman. We are just some. We hope, but we are not. We are crazy developers. We were not super crazy Superman developers. So yeah, this was around 5 to 6 minutes only. Yeah. So because everybody has to get back on Zoom as well, and or talk to the incident commander, and somebody has to take the deployment takes some time and all of that. But yeah, 5 minutes was something that we target. If an incident goes beyond 5 minutes, then it's the escalation starts, and nobody wants escalation when already users are.
Now it's making a change to the code and deploying a new artifact, right? The fix could be just turning off some feature flag. For example, in this case, if there was a feature which is breaking the app, I could just go on the feature dashboard and turn that off. So it would take hardly 2 to 3 minutes. No.
So the first basically you have to think as a first responder. The first responder responsibility is to minimize the damage, right? So for example, I on my home screen right now, I think there are around 20 to 30 feature flags that are working, and then experiments are going, thousands of experiments are going in the application, and one of the experiment or one of the feature flag configuration did this damage, right? The first responder's responsibility is to shut down that feature immediately so that users are not using that anymore, and users, their behavior, basically their usage is back to normal. Yeah, that is one of, again, shutting down the feature is one of the aspect. Then there are, for example, if is a backend service that has gone down, or basically it's an unhealthy system has gone, some unhealthy hosts are up high, right? So there are mechanism to reroute it to passive traffic and all of that. So there are automated pipelines. Again, there's no one solution to these problems, right? Feature closing the feature flag is usually the first hunch. Some feature must have broken it. Otherwise, some Datadog alert would have triggered already, then and there. Right?
The on-call team is generally much trained and empowered to take these decisions. That they can turn off a major feature.
Yeah.
Stability is going down.
Yeah, that's the kind of empowerment we have. Even SD1 or SD2, if he knows that, okay, this particular feature has caused this incident, he is empowered to go and switch off that feature immediately. No question.
Retrospectively notify everyone
Yeah.
that they should-
This is what I have done. Sorry? Okay. Okay. So so this data is generated over a window of 2 minutes on a sliding of 1 minute. So basically, for each 2 minute data that is being generated, this output starts creating, and then it moves to 1 minute of slide.
But it's not sampled.
It's not sampled.
In that sense.
The sampling is basically the rate limiting has a very, very high threshold, because that is just to prevent somebody going crazy. We don't want our whole analytics pipeline to go down, no? Because somebody just pressed ALL. Yeah. Yeah, cool. Yeah, so the strategic advantage, I think we have discussed strategic advantage as well. The challenges at scale that usually comes, so we have built these tools, right? So one we discussed very frequently is the scalability of the tool itself. If something goes with scale, the scalability of the tool also becomes question. The latency starts coming in the system. You get higher MTTR or higher detection time. The lack of features. So we analyzed a lot of observability tools, and there are only few that were giving us all the features that we want to debug such complex application. And the one that did had like crazy amount of cost. So we basically, not every organization can afford a very high cost of licensing and infrastructure cost, right? So that is one of the challenges that comes with scale. And incorrect calibration of threshold. Now, I think the developers are going to love me for this. So let's assume your engineering manager has set a threshold of every alert that triggers, you have to run. You have 10 developers in your team. All the developers then are working on any issue, at any given point of time. They're not working on something, building something new or all of like that, because you have calibrated the threshold incorrectly. So with scale, you need to define your threshold very, very well. What issue and how much users are impacted are then meaningful to you. If you don't define meaningful thresholds, your team will be wasting a lot of time in debugging feature issues or crashes or performance hits which are not even required or not even business critical, right? Because when you have 15 million users using your application at one point of time, there will be crashes, there will be performance latencies, there will be a lot of issues, but you cannot fix everything. Everything has a threshold, and that incorrect calibration saves a lot of time for your organization, save a lot of cost for your organization, as well as fatigue to your team. So that is one of the major challenges that people often overlook when they are looking at scales. So yeah, as I told you earlier, I am a director of mobile platforms as well as the open source. So we have launched the Dream Sports Lab. So I think most of the React Native developers here use Fast Image. Am I correct? So yeah. So the problem with Fast Image was it was not maintained. It was an abandoned repository. So we are maintaining the Fast Image fork, and we are now introducing turbo modules into the Fast Image so that the new architecture folks can also take advantage of it. We're also working on React Remote Components, basically server component for React Native application, our own MQTT framework, as well as one critical dashboard. However, if you can switch the tabs. This is a dashboard we published recently. So since performance is important to us, we also believe performance is important to a lot of you. What this dashboard provides you is an analysis of how React versions have evolved. What is their performance on old architecture or new architecture, and how your particular version, if you upgrade it to the next version, what is the performance hit that you are going to take. So it helps you, encourages you to take better decisions, because React Native upgrades are a major challenges. Take significant bandwidth as the feature grows. So you can, if you wish, you can use this dashboard to check out if your version are not. By the way, this is also published in This Week in React, edition 202 as well. So yes. Any questions? Oh, so Flink, sorry. Yeah. So Flink processor is nothing but a, let's take an example of an EC2 instance running an SQL query, right? So Flink is similar to SQL. It helps you write querying on a stream of data, and it provides a lot of tooling. For example, SQL provides you querying on a relational database, right? Flink is a language that provides you querying on a stream of database. Apache Flink. Yeah. So basically, the Kafka stream that is coming, right? It's a stream of data. It's not being stored somewhere. So you need to do processing on that stream. It's not stored in any table or any of that. So you need a querying mechanism to stream on that particular stream of data that is coming. And it provides you then a function like windowing, topple window, sliding window, and all of that. So certain out of the box functionality. So it's more like SQL for streaming.
Let's say you want to see how many users are coming from Mumbai in the last 2 minutes. So you could write some query like select star from users where city is equal to Mumbai and then apply windowing. So in the real time, you will be able to know how many users were from that kind of cardinality data, user, platform, city, anything like that. Correct, right, definitely. Basically, anything, any query that you want, because any dashboard that you create cannot support all the functionality that are in the world. If you have a custom functionality, you write a Flink query, you run it on basically the streamers operator, right, and it will start processing your data into a table. Yeah. Any other questions? None? Yeah. So just FYI, we are also hiring a lot of folks. So anybody is interested to join, particularly in mine or Weber's team, please do reach out to us.
We are hiring a lot of SD2s, SD2 and SD1 for front end as well as back end. Please reach out to us if you want.
We are working on very cool projects. So thank you guys.
So our next speaker, we have Jeel, who is going to talk about the alpha beta testing and how you guys can master it. Thank you. Hey everyone. I'm very excited to meet you all. And yes, my name is Jeel Soni, and I'm currently a software engineer one at Wayfair, a recent graduate. Like I graduated in July this year. So it's like I'm getting started and very excited for my professional journey. So yeah, thank you so much for being here. Yup. So today we're gonna look around how user experience can be increased with data-driven decisions and how can you master A/B testing. So I am assuming that all of you are professionals working in a companies from last 2-3 years or more than that. So you must have came across these A/B testing and the experiments going in your companies, right? I assume most of you are already, have been part of such experiments and could have known about the results they generate. But did you know that how old this A/B testing is? Like any ideas? The origin of A/B testing was from anything? Anyone? Okay, so this technique is around 100 of years old and the origin is from farming. Yup. So previously, farmers were very confused with which fertilizers to go with. So they decided to do the A/B testing. So what they used to do is they used to use 50% of their land and use some kind of pesticides and the fertilizers there, and on the other side they used to use the other ones, and they used to wait for the time and get the results on and then decide that which fertilizer is good for which kind of their whatever crops they are growing or whatever things they are doing. So which fertilizer is best for them. So from there, we did this, we got to know about that farming techniques and then we included it in our software engineering practices. This is interesting, right? Like how we adapted to something which farmers were using. But yeah, this was a great invention. Yup. So any one of you have any idea about Google's 41 Shades of Blue? You must have came across such kind of stuff on LinkedIn or Google or somewhere. Cool. Okay. So this was an A/B test which Google conducted around 2009. So here, what Google did is they wanted to change the Google ad link and the color of that. So they actually A/B tested it with 41 shades of the blue color. Can you imagine they're just changing a color of a link, description link, or that is going to generate an ad. They changed 41 colors to come up to a color that can bring immense change. And can you believe what kind of a revenue this one A/B test would have generated? Any guesses? Kuch some values you can just guess what it can be. Cool. So it was $200 million of revenue generated with this A/B test. Surprising, right? Cool. So when we are developing something, when we are moving in the development cycles, we just make decisions on our own, right? The user, we don't know about how the user is going to think, because sometimes user itself don't know how they're behaving when they're browsing. For example, if I'm going on Google, I might do some things which I'm doing subconsciously, which I'm not doing while thinking. So how a expert or a product designer or an engineering manager can actually drive that decision that okay, this user is going to behave that way? We don't know,
right? So this is why A/B testing is very important in such scenarios. Okay. So this is an A/B test result which we derive from like Netflix. So they saw that there is like 7.5% users who are more likely to like click on the thumbnail which contains Asian characters, while this Asians people are only doing this, right? But same thing, similar kind of trend they saw in India was like Indians were like less likely to click on a thumbnail which actually included Indian people. Right. Typical Indians, I know. So Netflix runs a lot of A/B tests on a daily basis on their thumbnails to actually see if what kind of thumbnails are getting clicked more and more. And this is a type of A/B testing which is like regional based, geographical based. Like if we just take a broader look at the this test on a like a whole world level, we could have seen some drastic changes in the analytics, which will make us like at a point that it will be difficult for us to make a decision. But if we look at such kind of A/B test result from geographic point of view, then we get to know that okay, some part of people's like some part of India or some part of a world is actually behaving some other way than the rest of the parts. So we have to actually look into the A/B test on the basis of geographical reasons as well. Cool. So these are some random test like results. So how you actually know that which version is better. So you drive that experiment and then you get to know about the results. So you can see a drastic change. But when we look into the data, it's not that bigger changes here. But the revenue is actually like increased. Like with few of the changes, there is an addition of $150 million in the revenue, which is like huge for any company. Cool. So why A/B testing matters today? So as I told that we cannot go with intuitive design decisions, right? We have to be more confined about how a user is going to react with our application, how they are going to see what we have built. So that is why A/B tests come in the role. And also, like we can actually get to know about the existing traffic which we are getting on our application and how they are reacting to it. So the like the chances of increasing our ROI with the existing traffic increases with such experiments. Also, there like if you have seen few of the UIs of an application, if they are having a lot of stuff and a lot of components on the UI, it's more likely that the user is going to bounce away. They may not get the conversion rates. So by such experiments, we get to know that which all components are not actually useful to our applications and that are making the users to bounce away. Also, if we are making few of the modifications, we never know that it can result into something drastically negative thing or may give you some positive results. So such kind of experiments also help you to know that okay, even if you're making some minute changes, you're gonna know that they are like going to risk your revenue or gonna help in that. With that, like you see some of the very significant changes in the statistics and analytics of your company profiles and other stuff. And also you can actually like redesign your whole application with the with new experiments which you actually don't know that how user is like the thing is that once we are a user, we want some new changes, right? As a user, we never think the way a company thinks, right? And a company can never think the way a user thinks. So sometimes these experiments actually make you go on a place where your company can make some components and some designs that a user wants. Let's move on to the next part. Okay. So after learning why A/B testing is important, what are the results of A/B testing? So anyone can like give what exactly A/B testing is? Any ideas you got from the previous slides? Like what is A/B testing or A/B experiment? Okay. Yes. So basically, like you are comparing two of the variations or two of the two components or two different type of versions of a same component, right? For example, you have a website, right, which have a CTA button login, for example. So there is a conflict going on between your team that, okay, let's make it green, and the other one is saying, no, let's make it blue. But you never know that which color is actually going to attract users. So user only know that what is actually going to help them. So A/B testing is basically releasing two versions of that same thing and making user decide that what they want. So 50% of your users will be seeing blue colored button and 50% of your users will be seeing green color button. So according to the data which you get from users, you can make a decision that, okay, so if my 50% of traffic was actually viewing blue color button, so how much clicks do I have? How much conversions do I have for blue color? And similarly, you can get the data for green color. And then you can make a decision that, okay, which is the best color to move ahead with, right? So like when I recently joined my company, I got to see that a lot of like early level engineers have this confusion between A/B testing and gradual rollouts. This is a basic, I think all of the early engineers have this in mind that, okay, so gradual rolling out is something like you roll out a same experiment or experience that you have, like for say 20%. Now the same experience, like the older experience is actually live for 80% of your users and the new experience is live for 20% of the users. Here you're not actually driving any decision or any data from that. You're just gradually rolling out, or you're moving towards a new experience. The reason of gradual rollout is that, okay, if you have some kind of blunders or some negative experience with the new one, then you can just roll it back. So it's not going to impact a large number of audience. It's just going to like impact it 20% of the users rather than the whole users. That's why we do it this way, like 20%, then 50%, then 100%. So here we are actually not doing any experiment in like getting to know about which data or which experiment to go with. But in A/B test, we actually drive the decision on the basis of data. That, okay, 50% of my users were actually seeing this version and 50% of my users were seeing this version. And now I have both the data that which actually version performed better and which I can actually move ahead with. So this is what A/B testing is. Cool. So what can be A/B tested? So when we talk about A/B testing, most of the things come into mind is like UI changes. But A/B testing is actually much more than UI changes. It's just not changing the color of the button or text alignments or image placements or just headings or something, but you can actually launch a new whole experience with A/B testing. For example, like previously, you have a website which have a enrollment process, but that is like page by page. Like now on a first page, you're seeing email and other stuff, then you submit, and then you move to the next step with password entry or OTP, and then you move to the next step, and like you have just like having a view switch on the whole page. But now you want to move to a new application experience where you want a single page application where you have all the like enrollment process on the same page, right? So you don't know that how a user is going to like react with that change, because the user was actually was basically doing that page by page enrollment previously, and now you're changing the whole experience for the user. So let the user decide that whether they want this new change or not. So then you can do a A/B testing on the behavior and get to know that how, okay, if you have new users enroll and you're getting more data and more customers to be enrolling than the previous one, then you know that, okay, this one page application is performing better than the other one. So this is how you can do it. So your UI changes, your experience changes, any CTA buttons changing or anything, you can do an A/B test with. Cool. So what is a workflow for A/B testing, right? So first of all, you need to have an hypothesis. Okay, like I told that you were thinking that let's change the color of that button, right? So you should know that, okay, if I'm changing the color of that button, it should actually give me some results. For example, if I say, okay, if I change the color of this button from red to green, it is going to increase my revenue by 10% or the enrollment by 12% or something. So you have this kind of hypothesis on your own. And then what you do is you just make the variation and versions that, okay, this is the previous version or this is the new version, and these are the things I want to compare. And then after doing this, you identify what are the like key matrices you want to focus on. It is a good practice to actually know that these are the key matrices I want to focus while experimenting with this, because sometimes what we do is we experiment on a lot of key matrices, and that makes a kind of blunder and doesn't give us a like a appropriate result. So for that, just identify different like different variables or different key matrices you're going to go with, then just run the test. But yes, while running the test, you like prior to that, you have to identify that, okay, are you going to do it with the 50% of your traffic, or you're not that much sure about the new variation that may like it may be something not that good, so you can just go with 2080. But it depends like how you're actually, but the way you are going with the experiment, you have to make your metrics accordingly. Like for 2080, you cannot directly drive the data because 80% of users were actually seeing A and 20% were only seeing B. So with that, you have to manipulate your matrices as well. So after you run the experiment, you get the matrices from the experiment. So now with this result, you can actually drive that, okay, my A version performed a bit better than the B one. So we can go with like 100% rollout of the A version. So this is how A/B test works. But yeah, there are some points where you don't have like a clear identification of the data. Like there can be a chances that A and B are performing like similar to each other. But at that point, you actually have to like rethink about your hypothesis and then make the changes accordingly. You can still take a call on the data you have, or still you can run some other tests over on that. Yeah. Okay, so what are the matrices that matter? As I told you that you have to focus on the matrices that you actually need for a business decision. Rather than going with a lot of matrices, just focus on the ones that you know that are going to make you drive a decision. So for like for UI or something, you can actually see for the click data you have, or for the enrollment data or conversions data. And for some experiences, you have to see that if the user is actually like returning on the application or just going away with the experience. Is it like enrolling from last of the steps? Like previously, if we had a lot of steps, view changes for the steps, then the user was actually moving ahead. But for the single page application experience, do you see the user is actually retaining throughout the application, or is it going away with middle of few of the like filling few of the fields and just going away? So you have to focus on those matrices on the basis of what kind of A/B test you're doing. Okay, with the A/B testing, we also have this multivariate testing. Okay, so any idea on what is multivariate testing? Okay, the something is written, but still. Any ideas on what it is? How it is different from A/B testing? Yeah, with the name, it suggests that. So basically, in A/B testing, you just compare two versions, right? Like just changing a color of a button, and in the second variant, the color is different. So both the variants are having different colors. But in multivariant testing, you actually test a lot more stuff together, like how they're going together well. So let me go to the next slide. Yes, so here you see the A/B testing, we just did that. We moved this from here. So these are two variations, right? But in the multivariant testing, we're actually changing a lot of stuff and seeing that how how all these components are going together. Right, so this actually gives you a brief idea of how your different components are going together, because this one is just giving you the changes with single component. That like if you're changing the color of a single component, you just gonna know that how this color is making decisions. But here you're actually changing the text, you're changing the placements and everything, and then you're changing some of the data in this, and then you are taking the decision that, okay, after doing a lot of changing to a site, how my application is performing and which of the variation is performing well. So rather than going with a single component or single variation, you can go with a lot of changes. But still, here you have to like make sure that you're not actually making it a bit clumsy and going with a lot of stuff, but you should be very clear with how you're placing each of the components with each other and how they're actually going to make it. Because if you mix match a lot of components, that it might give you some bad results and not accurate matrices. So for that, you have to be very precise with all the components you want to go together with. Okay, so in A/B testing, what are the best practices? So first is like test one variant. So you must have heard about ABCD testing, right? So they're actually testing a lot of versions. Rather than going with a lot of versions, try to stick towards one or two versions so that you can actually bring on the customers to what your exact changes is going to be and how they are reacting to the particular change, right? And then you can act. So what we do is like we run an experiment for almost 2 weeks at least. So 2 weeks is at least to get a better data and a like a static data so that you can make a decision on it. But sometimes what teams do is they don't run a test too long. So when you're not running a test too long, it's like it's a bit tough to actually gather the data and make a decision because you haven't run the test for a significant time, and that is why you don't have a proper matrices to actually look onto and make a decision. So rather than going with a short term test, just try to do it for at least 1 or 2 weeks so that you have a good data and you can make a decision on top of it. And also, like I have given you the example of Netflix, that there were changes on the basis of region and geography. So you actually have to look into that, how you're actually like getting the matrices on the basis of region and the geographical area you're targeting. So you have to isolate user segments, that okay, this is a user that they can behave in a different way, and we have this segment of users, they can also behave in a different way. So you have to drive a decision on the basis of different users as well. Also, like try to avoid biases, because like for example, if some kind of event or some kind of promotions is going on your application, at that time if you're running A/B testing, there might be a bit biases on the users that coming onto your sites, because sometimes the only users which are coming because of promotional events are youngsters, or the people who are using social media. So their point of view can be different from rest of the user. So try to make a clear and a valid user segment so that you don't like decide or come up to a decision which is only based on a biased users. Yes. So how can you actually practically do A/B testing in React? So as like we got to know that feature toggles are there. So any idea what are feature toggles? I think because of your talk, many people would already be knowing feature toggles. So feature flag, feature toggles are same. Any guesses on what a feature toggle is? Yes. So it's like you're basically like wrapping your feature around a toggle or a flag, and when this flag is actually turned off, that feature is not going to work. So sometimes what happens is, when you're running these kinds of experiments, there are chances of blunders. There are chances if the feature is not performing well. And that time, it's very tough to go to the code base, do the manual changes, and then deploy it. It's better to have a toggle feature on top of that, so that you can just turn it off. That's why that way you can actually decrease the effect of that particular blunder which was happening. So you can actually do feature toggling and use A/B testing with that. So how you can do it? You can have two versions. So this is the simplest code I could get to like explain. Like two versions we have. This is the variant and this is the control. And what we are doing is, if our feature is enabled, feature toggle, this one is feature enabled, is our feature toggle. And if it is enabled, then we're gonna see the variant version, else we're gonna see the controlled version. So we can actually set a fixed traffic or an audience for this feature toggle. Like for example, I can just say that, okay, this feature toggle will be on for my 50% of the users. So whoever will be like having this feature toggle on will be seeing the variant version, and rest of the people will be seeing the control version. So this is how you can do like precise and the A/B testing which is not going to affect users if something goes wrong. So feature toggling is the best practice you can include while doing A/B testing. Yep. So while feature toggling, or writing feature toggles, what are the best practices you can actually focus on? So sometimes what happens is, because of feature toggles, your code or your like the code base becomes so complex, because just imagine them as the wrappers over codes and features. So if you have a lot of feature toggles in your code base, it's going to make it bit complex, and it is like it may drive the performance down, because they have to go from a lot of features and then particular thing is like showing up. So it's better that you clean up the toggles after an experiment, or if your feature is rolled out for people and it's stable now, you can actually like clean up those toggles and make a like a precise code base. Then is like naming convention. So what happens is, when you're working in a company, there are a lot of feature toggles, and if few of the names are actually confusing, it becomes a lot more confusing to make a decision on that. Like for example, if we saw some feature is not working good and it is like affecting the users, you want to turn it off, but you have some similar feature toggle name, then it becomes confusing for the on-call person or the engineer to actually get to know that which feature toggle is actually affecting that or causing that. So be clear with the naming conventions and try to avoid some kind of confusions. With this, you can actually like monitor toggles and feature flags while they are in like running. So like for example, maybe your feature toggle isn't working, but it is on for 20% of the user, but you should know that okay, this feature toggle is working, else there is no sense of that A/B testing, because it's not actually working. So that way you have to like keep an eye on the performance of your toggle as well. Yep, so this was it about feature toggles and A/B testing. Any questions? So in my company, we basically use an in-house tool to drive this A/B test, where we have a lot of fields to fill. Like we can choose the number of variations and the versions we want to go with. Then we can choose the like we can divide the users on the basis of their GUIDs or their locations or the device IDs. That is better, because if you go with just browser cookies and just divide it that way, it is tough, because the same user can actually see a lot of versions. So it's better to go with the device GUID or the region if you're going with, or like anything, but it should be precise that a user is only looking at one variation, not multiple variations. First, okay. So like basically, when you're launching something for the very first time, like you don't have anything prior to that, right? Okay. So you have to like launch it for all of your users. You can do one thing, like if that is a single. Okay. Yes.
So when we are making when we start the application, uh, in the first launch, the experiment values are not fixed.
Okay.
Yeah. So let me repeat my question. So there is a problem in experimentation known as first launch. When you launch any experiment, so you have default values in your code, and then you have a control version as well as the variant one. Now the variant one, whether is assigned to this particular user, is going to come from an API, right? And when the user is launching the application, when this experiment launch post that for the first time, he doesn't have that value.
Okay.
Right? If you make that API call as a sync, then it start blocking and it start increasing your startup time. But if you make it async, then it start polluting your control as well as the variant versions, right?
Okay.
So how since you are using an in-house tool, I was just wanted to know your thoughts. Like, how do you solve this particular problem?
Okay. So like practically, I haven't come up with such a situation right now, but what I assume is that if you're making a very first call to the server to like see which version to show, so you can do one thing, that just divide your audience from server itself. Like there will be a division on the basis of users, that okay, for geographical one, you know that for that particular reason it's going to be the similar one. But if you're not going up with a particular user segment, then I think you can do something, is that you can, prior to the experiment, you can divide your audience. The traffic 50% is going to see this and 50% going to see this. So with the API call, you'll eventually have the data that okay, with this audience I'm showing this, and with this I'm showing this. So that can be basis on whatever parameter you're going up with.
Okay.
Anyhow, that audience will be going to click that same button, right? Whichever you are going to show, right? Either just yellow means that audience will be visible only for the yellow. Then obviously they have to choose the yellow, right?
No. Can you just repeat your question?
So you chose two questions.
Okay.
So based on the person you are going to show. I mean, random.
Based on the user, yes.
Okay.
That division is like
Yes.
random.
In that case, user having only one option, right? He don't have two options, right?
How? Yeah, the like a particular user only sees one thing.
One thing.
It's not
Then
going to
obviously
see-
you have to choose that only, right?
Yeah.
In case you want to proceed.
Yes. You have to choose that. But what we are trying with the A/B test is that, okay, if 50% of our users are seeing the yellow button, so are the people moving ahead with that yellow button? Like, is it catching the attention of the users? That is the decision we're making out of that. So the user is not going to choose that, okay, blue button or green button.
Yes.
User is not getting that
Option.
yeah, that is a thing. But the user, like for example, we have this room. We have like 100 people in this room, right? So 50 people are actually seeing a blue button and 50 are seeing a green button, right? So you don't know about anything such as like green button going ahead. You only know there is yellow button. So we got to say that this 50, how these 50% people are actually, behaving with that yellow button. These 50% don't know about anything going on, like such thing as green button. But they're gonna make a decision on the basis of how this yellow button is actually, looking, or how they are moving ahead with this yellow button. And the green button people wouldn't be knowing about the yellow button, but they're gonna make a standalone decision with the green button itself. So with the data coming up, we decide that, okay, the 50% performed better or this 50% performed better.
Okay. This is only for the testing, right? There is no functionality, right? In that case.
Functionality as in?
In case if I want to click that button, it should move on to the next page. Example, login.
Yes. That is the thing.
So-
if you're clicking on that button, you're moving ahead. That
Yes.
is the way we got to know that, okay, 50% may say, like 40% people actually moved ahead.
Okay, in this audience, almost 50 people is visible for the green, 50% for yellow.
Yes.
So obviously you want to log in.
Yes.
Okay.
Any CTA button is there. Yeah.
Any whichever is visible. So even 50 people, he will be logging yellow button. He also will be logging green, right? So how will be differentiate in that case?
The difference is that you have a landing page, for example, right? There would be a lot of stuff. But is that yellow button still visible to users out of all the content and they're moving ahead? Because there are chances that users drop off. Like, I don't think all the users who are going to a landing page are going to enroll or log in. So we want to know that what is the drop off rate for this 50% compared to this 50%.
Okay, on initial landing page.
Yes.
I have a question.
Yes.
And we are taking the survey from people that whether you like this button or this button. So we can do it for after 1 month also we will back on red or green. Right now login is there, everyone should have to do the login. So if it is a frequently used button, so in that case, how we will decide that red will good or green will good? Because people are giving feedback and feedback either we don't have to follow every testing in that scenario. We will follow different approach also. We will give after 1 month. Anyway, we will take same feedback from people and we will decide which was the good option.
Yep, I got your point. So you're telling that user is not having any option. The login is there. They have to click it. User don't know that, okay, I am a part of experiment. They don't know. The thing is, maybe that button is not visible or maybe that button is not catching the attention. So there are people who are actually going to the page and log in. They have this thing that, okay, we're going to log in, we're going to move ahead. So they are decided with that. But there are people who are not actually going to log in. They're just wondering. So that is the place where you hit your customers, right? It is like you have few of the fixed customers. They're going to come and log in, whether it's a green button or a blue button. But there are people who are actually the people you're targeting. You're expecting more customers to come up on your site. So there that buttoning makes more sense that, okay, if 50% users were seeing a green button and only 20% were able to enroll, that means that button is not placed right or the color is not actually performing better with the people. Right. But with the blue button, I saw 40% of the conversion rates. That means that, okay, people were actually be able to see that blue button and were moving ahead.
add on to it, right? A/B testing should never be done for critical. Okay, people always fail.
Yes.
A/B testing is only for an add-on. So we have done a 6 month of A/B testing for a project, and what we realized is it gave us it for 2016. And what we realized is it gave us a fact say X is your fact. But when we started adding it, right, we realized that that feature for over all the audience, we realized X was never a fact. So the biggest
Most of the time,
A/B testing
yes.
is always and always, right? It is very difficult to derive the user, what user really want is still the most complex problem to solve on this.
Yes. Because exactly, any type of user can come.
And the
N
time,
number of things, there are N number of things. They don't like the color, they don't see the color of the device.
Yes.
Kind of low.
Different
people say A/B testing should always and always get inspired.
add-on feature. Yes. Which you already have or you're trying to change. It works better with that situation rather than going with something eventually new. Yes.
It should always come from the product team. Developers have zero role. If you ask
Yes.
developers don't have any role to decide whether I have put X or Y. Right?
It should be like you act. That is the thing, right? Hypothesis is what matters. You should know that, okay, if I'm going to change this thing, it is going to bring more and more audience or conversions. So that is a thing which like business people are going to make a decision over. Because as a developer, we think that, okay, if it is looking good, it is best. We can move ahead with that. We don't want much more changes to coming in. That is the thing.
With that, we'll just take a break now. You guys can catch her up in the break. Now we'll go for snacks. We'll gather up here at 4:30. Feel free to go for the dry pantry, and we have like a lot of good food available. Take the first right and first left. You'll have a lot of things to eat.
Thank you, everyone.
Make sure to be back here by 4:30. Thank you so much.
Hopefully, I had the option to talk.
Hello, everyone. I hope you had a nice lunch, snacks. You enjoyed it? Okay. Any feedback? Was it good? Was something bad? That's nice. Okay, so now we'll go with the next speaker who is going to talk about AI with JavaScript using React.js. Please welcome Shreyansh Kumar Roy from Zebia.
Thank you, everyone. So myself, Shreyans. I'm working as a senior software engineer in GBA. So my topic, as you see, AI in JavaScript with React.js. So maybe you think about AI. Anybody know about AI here? How many people know about AI here? In a good manner, like machine learning, deep learning, or NLP, or something of that sort. No. So I am also in that category only. I'm a full stack developer, working as a full stack developer. But I was there in one of India's primary institute, and there I worked for Indian Defense. And there, the project was I was working in speaker recognition. So I went through AI and AI model and all. After that, later I changed my career to the as a web developer, full stack web developer. So right now I'm as a full stack web developer. So I think all of you know that most of the used language that we are using in AI is the Python. Everyone is as a Python developer. AI then Python will come into the play. R is that is a older thing and things like that. So the thing is that, but right now I will going to give some more context that how we can do similar thing with the help of JavaScript. So I know this is new for you. Most of the people don't know AI, and same like me. But the thing is that so the context of this talk is to not understand you AI. Those who know, that's great. Those who don't know, but see at least that when you do have some work of AI, because every field like economics, science, engineering, any field right now, we need the AI, whether it is mechanical engineering, also a machine learning model is there to do some perform some work and all. So now you don't know, that's fine, but later maybe you will going to learn because of some use cases. Like now, right now we do have multiple mobile app and web app approaching and all. They are like big industry also, companies also shifting to write the AI model with the help of JavaScript. I will give you one context about the Google Meet, you all know. So their background blur is happening, auto light adjustment is happening, all is using AI with the help of JavaScript. Why? Because Python is the best choice. Then why people are using AI or JavaScript? So the thing is that in Python, you know that Python and Java and all the languages is for backend. So we have to hit one more API to call that model, and which is written in Python or some other language to do the work. So, but in case of JavaScript, that is the beauty of JavaScript, because browser understands JavaScript only. So the thing is that if we will write somehow the model in JavaScript only, then somehow we will not have to call that API. So one API hit will going to save. So that's why people are hitting, usually now every web app and mobile app is integrated with somehow some AI enabled feature and things like that. So the thing is that the context of this talk is to give you the insight that how we can write some model in JavaScript. Even though you don't know, that's not the point of worry. Once you will know little bit about the ML DL part, then you will understand that how easy it is to implement. So I will give you the insight here to like multiple library like TensorFlow.js, Dense.js, neural network work, neural net.js, which is the counterpart which is already written in Python. Now this big company like this Google and all, like Google given the counterpart like TensorFlow.js, which is the TensorFlow. Those who know Python, TensorFlow and OpenCV and all are library for doing the Python related AI/ML work. So their counterpart like OpenCV.js is there, NLP.js is there, deep for neural network kind of thing, deep dense.js is there to integrate it in the real time without any API hit. And so that is the thing. So here let's start with the talk. So this is the linear regression thing. So linear regression is the basic thing of the machine learning algorithm. Those who don't know machine learning algorithm, they don't have to worry about it, because I know this point are new for you, but whatever I could do it in 20-30 minutes. So I will try to do it. Even though you won't understand, that's not a big point. Main thing is to understand how it can be implemented, how safely, how easily we can implement it in the JavaScript with few lines of code. So later also you can explore it. So these are the linear regression. Let's talk about the machine learning use cases, which is the backbone of AI. So let's talk with the linear regression first. So this is the linear regression, and you can see as it is a linear line. That's why it is a linear kind of regression, like which is following y is equal to mx plus c line. So as it is a regression, it will going to predict some value. But here in the graph, you can see it is doing some classification. So this is a two-class classification problem. I know these all words are new for you. That is same for me also. But the thing is that what I said, follow on that topic only. So linear regression, it is a linear regression. So it will going to, depending on y is equal to mx plus c, we will give some data, and it will going to train, like this train, test, data, like this classifier and all are new, I know. So the thing is that depending on that, whatever the data we are giving, it will going to predict predict the value depending on that data. So it is a linear regression, like using y is equal to mx plus c. While giving the training data, it will going to tweak out the m and c, like slope and intercept, and finally it will going to predict the value depending on the whatever the data we have already trained. Train and test are the two basic thing of the machine learning. First, as a human also, first machine is not human, so we are training with lots of data, like this belongs to cat, like we do have multiple images, like millions of images, and we are giving it to any kind of machine learning model, and we are making it that okay, this is level data. Level means this data, I know that this belongs to cat, this belongs to dog, this belongs to some other animal or something of that sort, and finally when testing will going to stop, like that we have to train with multiple millions of data, which is the deep neural network. In case of machine learning, it is not that much deep data, but still it is a level data. Like those value we know that is fixed. So finally we will going to predict, and finally after training with multiple image, we will give some more random image, like whether it is cat or whether it is dog and things like that. And whatever we have trained previously, depending on that, the neural network will going to, and any machine learning algorithm will going to tweak out their variable and all, like weight and all, and finally it will going to decide that this belongs to that category. So that is the main thing about any kind of machine learning or deep learning stuff, that finally after training they will going to predict any kind of random data. So this is the linear thing, and depending on this y is equal to mx plus c, and depending on the this best fit line, it will going to predict any value as it is a regression. And finally, it can be also generalized into two class classification, like cat is there, dog is there, that is two class. One class belongs to cat, one class belongs to dog. And finally, depending on that straight line, it will going to make one variable separable line that it belongs to A, it belongs to B, and finally it will going to give some kind of output. And there is some accuracy. We all know that machine learning or deep learning is not giving complete accuracy, 100% accuracy, but still 1-2 data mismatch will happen. But depending on that straight line, it will going to separate that variable using linear regression. That's the best I can do, even though you can't understand. So you can go and explore later this linear regression and logistic another thing. So these are the linear regression. Now you do have little idea, and this is the simple code that we can do in the JavaScript. This code I took the screenshot from JavaScript, and this is the normal code that we can do in the JavaScript to implement simple linear regression. As we all know that those who are machine learning expert, they are tweaking out their variable. They know that what kind of entropy to use, what kind of error to use, what kind of optimizer to use, and things like that to best fit the data. If it is two class thing, then if you want to predict the data, then we can use linear regression. If it is a multi-class thing, then also I will going to tell you that which algorithm to use and things like that. So those who are using machine learning expert or AI expert, they will use it. But even though you don't know, but you have some work to do linear regression or predict something, that is the normal use cases. You have some work to do, that you have already some model, and depending on the older model, you have to predict something. So this is the line, simple linear regression. Simple linear regression is there to finally call that API. It is already pre-trained API, and finally it will going to do your work. It is one kind of black box. You have to give your data, that this is the data, like 6 x and y kind of data, x axis, y axis, x axis, y axis data, and finally it will going to have some point in the space, two-dimensional space, and finally we will going to map the data, and finally we will going to predict that model using new simple linear regression model. And finally, we will going to predict it for like let's see. Now we have trained for 650 to 950, and finally we will going to predict it for 820, and it will going to give the output for 820. What is the output for 820 depending on that data? And this model will going to play a role, even though right now you don't have to pass anything. You are directly passing the size and price. You know, one x belongs to size and y belongs to price, and finally we will going to get the best result possible. Like sort is there. Sort is already implemented in some languages, which is giving best time complexity, like log n best 2. And some people know how to implement sort. They are also implementing sort. So like that only we do have flexibility whether to use some model which is already pre-trained, if you are as a black box, or if you know something, and maybe after working for 1 year or after working for 6 months. In my case, I worked little, so I know little bit about the machine learning. So whether to not use black box and tweak some parameter depending on our data set and all. As you know that this data belongs to linear curve xy, so you are directly using simple linear regression, and finally you are predicting the price. This simple, the thing is there in JavaScript, like using React.js, and as it is written in React.js, we can generalize it to multiple things. Like as you know, all are full stack developer mostly, so using npm we can generalize it to Node.js also, we can generalize it to React Native also, and many more, and things like that. So like that only, this is the linear regression, and this simple line of code to implement the linear regression to predict some value depending on that data. How simple it is. XY you are finally giving, and finally you are calling that API to give the prediction. And now coming little more use cases, like this is the TensorFlow.js library. TensorFlow is maintained by Google. So the thing is, yes, thank you. So this is the TensorFlow library. So TensorFlow is the one of the main library of Python. Now PyTorch came into the picture and all that have more accuracy and all. But TensorFlow is still many people are using it. So TensorFlow also came with their JavaScript model to implement it in real time. And this Google Meet case, what I said you, Google Meet automated AI and the new app of the Google or big app are using this TensorFlow or different kind of library also only to implement. So here you can see here directly they are not using that black box one API as a black box. Here they are creating first sequential model. So I know this term are new for you, sequential model, like 2-3 layer of model is there. So first they are adding one sequential model in TensorFlow, and finally it is finally we are giving the data again to tensor data. Tensor is one kind of matrix. That's why the name is TensorFlow. So I know these are new for you, but once you have some work in AIML, and I know very well that you do have some work of AIML, because now new app, new feature app, web app and mobile app is also integrated with multiple AI. Maybe as a full stack developer, you also have use cases to do AIML work. So if you will go with little courses of AIML like NG or something of that sort, then you can easily understand this small terms. So these are the intro, like these are the, here you can see model.compile is there, that mean squared error is there. So mean squared error, as I'm talking about the linear regression, so mean squared error is the main, like depending on the X value and Y value, finally we are giving we do have multiple loss kind of things. So depending on data set, as we know, it is a linearly separable line. So we are giving mean squared error is the thing, and optimizer is this SGD. So statistical gradient descent. It is a way to it is pure mathematical term. It's a way to minimize it to local minimum, like it's a Bayesian curve shape to minimize it to very less loss, we can say. So you can understand in that sense that it is giving minimum value, like it is giving minimum error. So we are giving a mean square error, and to get more and more accuracy, we are passing it to a statistical gradient descent optimizer, which is like Bayesian shape curve, and which will make it to the global minimum position, this position of the Bayesian curve. And finally, it will going to compile our model depending on that. Here you can see that we do have some flexibility to use this and this depending on our data set. And finally, again, we are putting X and Y value using tensor. It is a kind of matrix. And finally, we are here we are giving epoch also. Epoch is some kind of thing. You can say how many times train will going to happen, model train will going to happen. We do have lots of data, as I said, the cat and dog example. So we will going to, how much time we will going to train it. More and more training we will going to do, that this belongs to this in a level data. When you know the data, exact data, then more and more approaches we will do, more and more iteration we will going to train. So more and more our model will going to predict, and it will going to give more and more accuracy, like 90%, 94%, 95%. When we come with some random cat image or dog image, then it will going to predict maximum, because finally it is internally doing the calculation that landmark and all, what is the face dog landmark, what is the cat landmark and all. So more and more iteration and more epoches is there, so it will going to give more and more models. So here, even though you do have flexibility of giving epoches, 500 epoches, and finally you are predicting the value for 820, and it will going to print you the thing. So here, as those who know basic of machine learning, they can easily choose loss and optimizer and epoches. Epoches is depending on how much use cases you do have. If you will increase epoches too much, then your app will also go little slower and things like that. So here they are giving more and more flexibility to use your model rather than hitting one like black box API and all. So that is the basic thing. Using TensorFlow JS with this simple line of code, you can implement it. And same thing, this is the neural network. So neural network, I will talk about that also. Neural network is also one library. Neural network is like human processing brain, like kind of multiple parallel processing is happening in neural network. So the idea came from the human brain concept. Human brain have multiple neuron and all. That's how this idea came, that how to do human related tasks with the help of AI using this multiple parallel processing unit. I will talk about this neural network. Now you can think about this neural network.js is library. Finally, we are again giving the data. Input is this, output is this, and finally here we are creating new neural network model, and here we are passing two parameter depending on our use cases, and here also, and finally we are again making iteration. We are fixing the iteration 1500, 200 and things like that, and finally we are predicting for the new data. Depending on this old data, it will going to predict for the new data. So these are the many variants for doing linear regression. Why I showed you 2-3 example, that is different one thing library, and one thing that if you are a complete beginner, then also you can use. If you know the machine learning expert, also you can use. If you know basic of machine learning, then also you can use by check tweaking some parameter or knowing the basic machine learning or AI related stuff. Now coming to the logistic regression. So the like I took few main machine learning use cases or AI use cases, and I showed you the how it can be implemented within 4 or 5 lines of code only. Even in Python also it can be implemented easily, and even in JavaScript also it can be implemented easily. So if as a JavaScript developer, if someone comes with some use cases, then you have to go with JavaScript. You don't have to again learn Python, even though you know Python, you don't have to switch the language, because you know the advantage here. That's why the big company is shifting toward the JavaScript, because here one API hit will going to like reduce. So that's the main thing. So logistic regression also like it is a like true false kind of thing. That linear regression, it is a kind of two class, and logistic regression it is true false kind of thing. Like when you have the use cases like true and false, like some use cases like cat true, cat false, and things like that. If like cat is the image, cat true and cat false. So logistic regression like logistic, like it is a true false kind of yes no kind of thing. So if you have this kind of data, when you have to predict that is it belong to that class, true or not true, finally we will going to use our logistic regression model, which is the most used model, and later only this kind of model can like complex model is developed with the help of this basic model, logistic regression. But it is very powerful in some data cases. When you do have that much use cases like yes no or true false value, then this will going to give you maximum accuracy. So these are the like logistic regression 0, 1 value, and 0.5, it is a sigmoidal kind of curve. I know these all term are new, like we are doing it in our 12th or like undergrad and things like that, but still I'm telling you to see it, that how easily we can implement it in JavaScript. So when you do have the use cases, when you learn the basic of it, then you don't feel that now we have to choose Python over JavaScript. So this is logistic regression curve. Here output is 0, 1, and it is a sigmoidal S-shape curve, and finally 0.5 is the between line, and finally either they are giving output 0 or either they are giving output 1. When you do have the data, depending on that data whether you have to predict either true or false, you will use this kind of activation function which will going to feed in the machine learning layer to give more and more accuracy. So this is Bayesian like a sigmoidal curve. And finally, now come to the implementation. So same thing like logistic regression. Right now, I'm using ML library. You can see I'm changing the library also. Like TensorFlow.js, I have used like TensorFlow.js. I will use neural network.js. This is ML.js. Like that, we do have too much flexibility to use different library, and they have different options whether to use as a black box, whether to tweak some parameter, whether to tweak more parameter if you are expert or things like that. Here, depending on that, we are giving data 0, 0, 1, 1, 0, 1, 1, and finally we are leveling it, that if it is that space like 0 xy coordinate is there, and it will label is that this 0, 0 belongs to false, 0, 0, 1 belongs to true, 1, 0 belongs to true, and 1, 1 belongs to false. Like we do have some data set and we are training, and finally we are leveling it that this data belongs to true, this data belongs to false. You can generalize it to any of use cases, like you had to have some use cases and all. And finally we are doing, again we are hitting that logistic regression API, and we don't have to pass anything. We just have to pass training and level, whatever the training data set, whatever level we do have defined. And finally we are predicting the value depending on some new use cases, whether it will belong to 0 or whether it will belong to yes, 0 or 1, or yes or no, or true or false. Finally we are predicting. This is that simple thing is there if you are a beginner. And finally, let's come a little bit more about this using TensorFlow.js. Again, we are defining it with the help of matrix as it is a tensor. So, and finally, again, we are initializing one sequential model, and here we are giving activation, size, shape. So as I said, sigmoidal activation is there. So that's why this bell-shaped curve, yes or no curve. So it will going to give maximum fit. So that's why we have not given any kind of other activation. We have given sigmoidal activation, and finally this optimizer SGD most of the time we are using, because that is giving global minimum error, which will going to increase our accuracy most of the time. So, and loss is binary cross entropy loss, because those who know the entropy is also working on true false kind of thing. And finally accuracy also, here we are providing metric accuracy. These are the basic thing. If you will search that TensorFlow.js and things like that, model.compile is taking which kind of parameter and things like that. And finally we are passing hypothesis, how many times that training will going to happen, and finally we are predicting the value. So here again we do have some more use cases. If you know little bit term, then you can tweak out the value, and you can play with the accuracy what you are getting in. So, and again, brain.js is there. Finally, we are again putting here sigmoidal activation function, hidden layer, as it is a brain.js is also neural network, like too many layer is there with parallel processing unit and all. And finally, again, we are giving the data and labeling that 00 belongs to 001. And finally, again, after changing the iteration and all, we can here change the iteration, and finally 2-3 more parameter, and finally we can able to predict. So this is the simple line of code is there to implement it in the JavaScript. You don't have to run behind any other Python or things like that. Python also very simple. I'm not denying that, but the thing is that JavaScript also give you same thing with that simple line of code. The kind of understanding you do have, you can choose the library depending on that. And now coming to the one of the most used cases of machine learning, which is support vector machine. So support vector machine, like it is also depending on two class classification. This belongs to one class, this belongs to one class, and there is a plane which is called like normal. In 2D we are calling plane, in 3D we are calling hyperplane, even in 4D we are calling hyperplane, and things like that. So hyperplane is there if you think that it is two-dimensional. Normal plane is there. In case of multi-dimensional space, it is, we do have two set of data, and finally we are making that separation maximum, which is the support vector machine concept. Like mathematics, if you will go, that is norm omega squared and norm omega squared, we have to maximize. That is different thing. I don't want to confuse you all people. So the thing is that I also don't know that much mathematics and all, even though I know at that time after 4 years I forgot most of the things, but I don't want to forget the machine learning and deep learning thing as a full stack developer. That's why I'm trying to do it with the help of JavaScript. So finally we are separating this line with the help of that norm error, and finally we are separating some error will going to happen. We are separating two class, which is the support vector machine concept, and it is a vector in a space. That's why the support vector machine is named introduced for this. And finally we are making the maximum margin, and this is the hyperplane. As you talk about more than 2D, then hyperplane came into the picture. These are the mathematical terms. Even though you don't know, you don't have to worry about it. But SVM is support vector machine is one of the most building block of machine learning algorithm and all. And now finally going to their implementation. This is the simple implementation using this MLSVM. Yeah, I've given you again new library. MLSVM is there in JavaScript. You can download using npm install this library, and finally you can use their. Finally, you are training with the data. Now you know a little bit about training data. I don't have to explain that much, like 0001. And finally, we are mapping the data. And here we do have some flexibility to use RBF, like radial basis function is one kind of kernel we are using, and the cost function and all. I don't want to confuse your cost function and all. Those who know machine learning, they will decide. Normally, you can use one, but is there in there, there's a documentation page and things like that. And you can predict it for the normal use cases. What is the value for that unknown data. Training we did, and for unknown data, what will be the value? And again, with the help of TensorFlow.js, also we can do. Here we are defining two tensors like matrices. We are labeling the data in the space, and finally we are starting sequential model. Here also we do have some kind of flexibility to choose, like activation, which I want to use here. They have used sigmoidal activation like this only. And finally, input shape is to like how many layer will be there, how many input layer will be there, and how optimizer same stochastic gradient descent. And finally, mean square error minimum. And finally, we are making the hypothesis. It up to me that how much accuracy more we want. We want more accuracy. We will train it. We will pass the training data to the model more and more time. And finally, we will going to predict with the unknown data, and it will going to give the accuracy with good accuracy. If you are this and this is fine with the data set. Like if you have linear, then you have to pass linear kind of activation. If you have logistic, you have to pass sigmoidal activation, and like that your activation and all is fine. Then it will going to predict most of the time accurate data only. And same thing is with the help of brain.js also. Here we do also have flexibility to use it, and finally we will going to predict it for the new data like 0.5 and 0.5, and finally we are training. So see, this 5 line of code only is simple is there to implement something and predict some unknown value. That machine learning people are telling it is very hard, this, that. Yeah, it is hard, I'm not telling, but the thing is that as a developer, we don't have to sometimes know everything. Now we just have to do our work. If work is simple, then someone is giving some Excel sheet, they have lots of data and they want me to predict something. We will go and we will directly use any kind of black box, or we will use the basic thing from their documentation that this data suits which kind of model and all, and finally we will going to predict the value. And every time I'm using new library, those three libraries most common. One TensorFlow JS, one is Brain.js and all. But multiple more library came into the picture in JavaScript, and too much funding is also happening from big tech company to implement it in JavaScript, because they are also heavily implementing that YouTube comment, spam comment detection. It is happening on real time on web. It is not hitting any API. With it, their whole model is written in JavaScript only to implement it in the browser only, rather than hitting one API and making delay and things like that. So now coming to the neural network, I said that one slide was there for neural network. So this like main thing, AI, what is AI? Like we people are thinking that human will able to think like machine will able to think like human can think. So like then they have gone through this, like neuron and all is there in our brain and all. So they saw one pattern, like there are too many neuron interconnected, very complex interconnection is there. Like that they have also maintained one kind of like neural network kind of concept, like where there is too many layers and all are connected with each other using, and that is called deep neural network. When you do have too much data, too much layer, then it is called deep neural network. Like this is the backbone of deep learning. Like too much deep data you do have, and you have to pass it to multiple data. So too many interconnected parallel network is our human brain concept also. And finally they have also implemented it with the machine learning model, and that is the concept of neural network. So neural network, as you go through it, neural network is a biological, using our biological neural model it have implemented. And finally we are passing the training data, and while training the data, when we know that this data belongs to this category, like first time cat and dog, finally it will going to pass depending on which kind of activation and all we are giving. Finally it will going to pass, and finally we know the output at that time, that this belongs to cat, this belongs to dog, this belongs to this. And finally first time it will come, and finally it will going to back propagation. Back propagation is one of the main thing of the AI. Back propagation algorithm will work, and it will going to, there is a weight, like y is equal to mx plus c, you can say. There is a weight, like it is always going to tweak out that weight and bias and things like that, because they know input, they know output, and it will going to train our model, and they will change the model and they will change the weight for that particular input, so that next time the new thing will come, then depending on that weight and bias calculation, it will going to predict for the new output also, and the fair enough accuracy, depending on if your input is good, like in case of logistic, this graph, linear, this graph, and things like that. If your error is good, even though you don't know, so someone already implemented for you, so you don't have to worry about it. And finally the main thing is that this is how the weight and bias is calculating. And finally for the any random data also, when too many postures or iteration if you are giving, then too many times this whole back propagation is happening for input output, and it will going to tweaking out the weight and bias in a good manner. And finally when some random data also came, when we have to predict something, right now I don't know which class it belongs to, whether it is cat or dog, then finally depending on their calculation and all, weight and bias, it is already fixed while training, it will going to give the accurate result. So this is the idea behind any kind of AI model, which is neural network, like human brain concept. And finally, how we will going to implement neural network, you can see another 5-6 lines of code is only there to implement the neural network also. Here the input output, I don't have to explain that many times. Now you know that input output data, like this is a space, this belongs to 0, this belongs to 1, this belongs to 0. And here they are giving kind of what kind of iteration you have to choose. And finally we are using node brain. See that this is another library, node brain library. Like that we do have too much flexibility, like a Python developer to use any kind of library and do our work, whether it's a beginner, whether it is a mid-level, whether it is expert level, and things like that. And finally we are predicting the value for unknown kind of data. And finally this is how the neural network, basic neural network with 1-2 dense layer, or even you can change also, you can use some different library to change how many dense layer you want, how many complex data you do have, and you can choose many dense layer, so that weight and bias will going to fix for more and more dense layer, so the your accuracy will be more and more. So even though it will going to bypass in one layer, one more layer will going to check, no, this data, I have fixed this weight for this cat category, I have fixed this weight for dog category, and things like that. So more and more dense will be there, more and more accuracy will be there. That's why the machine learning, deep learning is giving more accuracy than machine learning, because deep data is there, too many more ultra processing layer is there. So like that also, this is same thing is same thing with the TensorFlow JS also. We can use some kind of activation function and unit, and finally loss and all. Here they are giving some kind of flexibility. If you are a machine learning developer, you think that this black box is not giving some kind of accuracy, good accuracy, then you can choose, depending on your data set, you can choose different algorithm, different model. You can go, you can take the which kind of model is available for this kind of data. You can change the model, and finally you will going to predict, and finally we will going to give you the output depending on any unknown data. So this is using brain.tensorflow.js. And same thing with the help of brain.js also. Anyway, brain.js, everything they are implementing with the help of a neural network only. And simple, this is the simple line of code to implement one and predict some thing for the random data with the help of neural network. I have taken the easy example. Code is like that only. Even though you do have some complex of data, you can pass it with the help of Excel sheet in the array, and you can directly implement. You do have some JSON array or some matrices for cat, some matrices for dog, and things like that. Finally, you are storing somewhere and things like that. You do have some labeling, and finally you will able to predict with the big data also. So no, this is the supervised learning. When you know I'm going out of the time, so I will go a little faster. So this is the supervised learning questions. What I tell now. So where we know that already output depending on that input. Now coming to the unsupervised learning cases, where we don't know that which class it belongs to. We don't know initially also that this belongs to cat, or it belongs to dog. Finally, while training also. So these are the some algorithm like clustering algorithm. K means clustering is there. Here we know this data. Here we know that this is a 3 category data. So that finally we are making one random point, and using K means algorithm, always this will going to calculate the mean square distance and all, and finally it will going to give, like as we have given 3 cluster is there, so it will going to predict 3 cluster depending on the Euclidean distance and all. It will going to predict 3 cluster. Now previously your data is unleveled, now it is data is leveled. You know that this class belongs to A, this class belongs to B, this class belongs to C. Any example, like you take animal, you take any kind of insects or things like that. Finally again it is a level data. You know, while training, you know that this class belongs to this class belongs to this, and this class belongs to this, and finally you will able to apply same algorithm that we have discussed in the level data while training, and finally you will able to predict the data on random kind of any kind of unknown data. And this is the basic JavaScript code to implement the K-means algorithm. Like sklearn is the one API that you would have to hit, and you can define the how many cluster is there in these 2 data set. They know that 2 cluster is there. I don't know which cluster is there, but 2 cluster is there, and finally it will going to give you the result depending on that cluster. And finally you will able to pass it out with this linear regression, SVM and all as it is. While training, you need at least level data where you know at least it belongs to that category. And this is the PCA, principal component analysis. Sometimes we do have lots of data, and we don't know that we don't know like this data. Like we know that this small data only is giving some kind of feature, some kind of more feature into that, and all other data is not that much important. So here we are doing the dimensionality reduction kind of thing, which is PCA, which is principal component analysis. We are taking the data, we are taking out the principal data out of it, which will going to play any role and all. So this PCA is one of the main thing in machine learning to reduce the dimensionality when you do have lots of data. And finally, with that simple line of code using PCA, by calling this PCA API with the help of scikit-learn. Scikit-learn is a main Python library. Scikit-learn JS also came into the picture now. They have given enough funding to develop their library, and it is going more and more nowadays because more and more web app and mobile app need fast executive AI model. So finally, using PCA, we can reduce the dimensionality of your data. It will going to give the main data, principal component of data only. So these are the unsupervised learning use cases. Now coming to reinforcement learning. Reinforcement learning is somewhat more evolved machine learning use cases when you don't know anything. So using the reward and penalty kind of system, you are doing something here. You know that this is the destination point right now. I am here. So I will take a step. It will going to calculate the distance from the destination, and finally it will going to, if I am going near to the destination, it will going to give reward, and if I am going away from the destination, it will going to it will going to reward and penalty. It will going to give penalty, and depending on depending on that only we will going to predict, like this snake game and all we are seeing. So if you will implement that in the AI, and also depending on this reward and penalty only, this reinforcement learning will going to come into picture. Their implementation is a bit complex, so that's why I have not added to confuse you, but it is not that much complex also. Trust me, it is one more slide will be going to be added, like to write a model for reward and penalty, and finally for any random kind of machine learning use cases when you don't know anything about anything, like not even clustering thing, not even any kind of data set, but in case of reward and penalty, if you will train, then you do have some idea that we are going in the right direction or not right direction. And now coming to the computer vision use cases like face recognition, face detection and all, and there are multiple library for that, like OpenCV.js is there, Face API is there, TensorFlow is there. TensorFlow was one Coco SSD model, which is already pre-trained for human face, and you can easily call that API and detect the face, like face detection, face recognition. Also, like after detecting the face, you do have already someone face matrix is stored. Finally, you will be able to predict that in our database which face mostly it is matching with, and depending on that, whatever the threshold you have given, that if threshold belongs to that category, then match with this X person, if threshold given to Y category. So like that only face recognition will also happen. These are the library which can give your do your work, face recognition and all, even though you are doing for your CCTV and things like that. I have there in one kind of police software. I was there in one, they are providing software solution to Indian police. There I worked on CCTV intelligent monitoring, and I have used this face API JS model only to implement everything in the JavaScript only on the web rather than hitting any Python API. So these are the face detection, that's eye is there, landmark, like that is called landmark detection. Already some pre-trained model is there, they know that this belongs to nose, this belongs to eye and all. Finally detection will happen out of your whole body, where is your face. And finally, these are the library for face detection. See, this is the simple use cases for face API.js is you are using. You are you are doing npm install face API.js, and you are using an canvas. Canvas is like that rectangular curve. Those who know React, they know. And finally, we are detecting the face from that API using face detect face. Using detect face directly, we can pass one image, and it will going to give the idea that where out of the whole body where is the face is there, and that it will going to put that rectangular canvas there. So using that pre-trained model only with this simple line of code, you can detect any image faces and things like that. And finally, if face detection will happen, then finally you can do face recognition also if you do have already face data and you the tensor of the face data and things like that. And finally, using this OpenCV.js, they have their one kind of HAR cascade front end. Those who know signal processing, all electrical engineering background, they know HAR wavelet and all. I think it is not in BTech, but usually HAR wavelet and all is there. And finally, using that HAR wavelet.xml, it is predicting similar thing. Detect multiple. Here you can detect multiple faces also. Like let's take 10-15 people are there. You can detect directly the 10-15 faces out of the whole body. Where is the faces, which person faces and all. And with the help of this also, older one also, you can do similar thing, detect multiple one faces also, whole image faces also. So these are some library. Don't be fearful with that. These are easy only. We are directly doing, and here we are doing the thing with the like point and all canvas mix. Normally these are the only thing which will going to do our work and things like that. Whatever the pre-trained model is already given for Coco SSD and all for object detection. If some object is there, they have multiple trained object like this. This belongs to bag, this belongs to bottle and things like that. So you can do multiple use cases. You don't know now. As a full stack developer, in your app, face detection will be there, object detection will be there. You can directly use within 4-5 line of code, you can detect something. And finally, the face detection happen. Then if you do have already the data, as I said also, then you have already data like tensor, like matrices of someone who have already faces. Depending on there also, you can give the threshold value that your accuracy will be like that. And once it will going to give the threshold, like it is matching up to that 0.5 or 0.3, then you can directly predict that this person belongs to that, this function belongs to this. Like face recognition also similar way it is going to happen. And now I have not added a slide, I am running out of the time. So like that NLP use cases also, NLP like this chatbot, Gen AI, all the things. So NLP.js is a library you can directly use to do any kind of chatbot implementation, to do any kind of like speech to sound signal processing and things like that, like speech to text and all things can be implemented with the help of that API. NLP.js library is there, and there are multiple counterpart library also is there to do that work and all. And apart from that, still data science is not belong to AI, but still data science best choice is Python only, because there are pandas, numpy and all libraries there to deal with the multiple big data. Even in JavaScript also too many libraries like Excel to JSON and all came, but still for data science I would say that Python is the best choice, because we don't need urgently at that time data like our model only. So because the one API hit we can directly do with the help of that. one one API hit we can directly do with the help of data science, so no problem with that. So the especially for the AI kind of work, now actively this big company is funding for JavaScript model rather than hitting one more API, because here the execution is fast and it is simpler also. So as a full stack developer, you need to know that we can do everything with the help of JavaScript also rather than hitting Python, because sometimes we don't have choice, like especially Google image background detection and things like that. You can't have any choice. You want the result as faster as you can. So that is my context of this talk, and maybe you do have some question also, that usually this machine learning, deep learning requires too much processing. Like you do have multiple core CPU, TPU, and things like that. How browser with the help of browser only, how we will able to do? So these are open. These are a very big question when this big tech and think about the JS implementation of the AI. So they came with this OpenGI one library is there. By default in the browser only, they are using your device for this big and complex model calculation in the AI also, so that even in your device, whatever the core you do have, whatever the processing you do have, they are using your thing only to calculate the to predict the model and things like that. They are not coming behind the box from the browser, because browser don't have that much flexibility to run with that complex model. It is running on normal V8 engine, we know, as a full stack developer. So that's the talk, that's the context of the talk. Don't be fearful if you don't know the word, and like big word, I know that it is a complex for the beginner, but my main thing is to give you the context that how it can be easily implemented with the help of JavaScript. So thank you.
We have our next speaker now, Pulkit, who is going to talk about demystifying user interaction in smart TVs. Please give him a huge round of applause.
Hi everyone, my name is Pulkit and I work as a front-end engineer at Amazon. And today I'll be talking about demystifying user interaction in smart TVs. So when you talk about interacting with a website, the two major interactions that will come to your mind are clicks and scrolls. But what if these interactions are taken away from you? And this is exactly what happens when you work with smart TV apps, or when you actually, operate on smart TV apps. Let me give you an example, right? So this is a typical interface of a smart TV app where you have a side nav. Okay, you have some tiles where tiles have some cards. Now, the important thing to note here is that when you are interacting with this smart TV app, you do not have a mouse in your hand. You have a remote. You can navigate through the left, right, top, bottom. And when you're going from the card to the side nav here, you're not actually clicking. You're moving the focus from the card to the side nav. Okay, you're moving the focus. And as soon as you move the focus to the side nav opens up. So remember, you're not clicking anything. You are moving the focus. Now, let me give you another example. Yeah, so have a look at this example. So you are moving, you are pressing the right button and then you are moving horizontally in the card clay. So when you press the down button, yeah, let it come to the card. Yeah, when you press the down button, the tiles scroll up. So it might occur to you that the scroll that is happening here is running, it's working out of the box, but that is not the case. So when you're working in the web browser, when you scroll, the scroll speed and everything, browser handles everything out of the box. That is the responsibility of the browser to handle scroll and everything. But it might look like the scroll is being handled by the application, but that is not the case. It is being handled manually. The person who's developing the smart TV app has to handle this. So when you're moving, when you're pressing the right button, the tray has to scroll horizontally. That is also manually handled. When you move from one tile to the other tile, the tile has to be scrolled. That is also manually handled. So these things have to be handled manually in smart TVs. Okay. Now, to the naked eye, it is visible that when you move from one asset to the other, or let's say I press the right button here, the focus moves from one element to the other. To the naked eye, it's visible, but someone has to calculate, right? someone has to calculate where the focus has to shift. When you press the left button, when you press the up button, something has to calculate that. Okay. So I'm going to talk about a focus library that it's called N origin spatial navigation that performs this focus, moving the focus from one element to the other based upon the button that you pressed or based upon the navigation. And one important thing to note here is I am only talking about web-based TVs, for example, Samsung or LG. I'm not talking about Android-based TVs like OnePlus or Sony. Apple has its own ecosystem. I'm only talking about Samsung and LG. Right. So, like I said, there are other open source libraries, but I will be talking about N origin spatial navigation. The reason being that I've worked on this, but the focus libraries are the other focus libraries that are available in the market. They also work in the similar ideology in terms of calculating where the focus has to shift. Right. So, yeah. So one important thing is when you use this library is not going to traverse your dormitory or go through your dormitory. Okay, it's not going to do that. You have to tell the library what are the focusable elements on the page, because there might be cases when there are elements on the page that you don't want to be focusable, right? So you have to tell the library explicitly, okay, I want this element to be focusable. How do you do that? So so that you can use this library in React, this library will give you a React hook, which is called as use focusable. It will give you certain options like refs and focus keys. So focus key is something you can also provide, you can hard code, but if you do not give a focus key, it is going to assign, let's say, a random focus key to that element. Now, I'll give you just what is happening here. So I want these three elements, list item 1, 2, and 3 to be focusable. But see, I have wrapped this in a div and I provided that ref to the div. So what this focus library is going to do is it is going to associate all these three list items with this ref. I mean, with this ref as in with the container that they are encapsulated in. Okay. So it is going to assume that all these elements are focusable. Now, the question that might be coming into your mind is I want list item, these 1, 2, 3 list items to be focusable. Why do I want to wrap this in a container and give that a ref? See, when you give this container a ref, this focus library will define a parent focus key, and the individual elements are going to have their own focus key. So every individual element will be associated with the parent focus key, and we are going to see later why this is important. For now, let's settle with the fact that there will be a parent focus key and a child focus key, and this is required. I'll tell you why. I mean, you can go the other way around, but why we are doing it this way, I'm going to tell you later. Okay. So, and yeah, one more, this is just the visual representation of what we just saw in the code. These are the three elements, list item 1, 2, 3. I want this to be focusable. So the outer container, this outer container is the one which has the ref and which has the parent focus key. So it might look like it will have the focus, but focus will only go to these three elements. Okay. It's not going to have the focus. I mean, a visual representation, it might look like the outer parent container is going to have the focus, but you will, I mean, when I take you through the examples, you will notice that the parent container does not have the focus. The purpose of giving it the ref is just to associate these three elements with the parent focus key, and I'll tell you why that happens later on. Okay. Yeah, one more thing. So this library internally creates a map of the focus key to the element. When you tell this library, okay, this is the focusable element, internally it will create an internal map of the parent of the focus key to the element. And when it creates the map, it will associate certain properties to that element, which it will later use to calculate the focus. Okay. So when you register an element as the focusable element, this library is going to associate certain attributes to it. So it uses get bounding client ret, which is very widely used in the front end ecosystem. Bounding client ret can give you certain things like top, left, width, and the height. Consequently, it calculates the 4 coordinates of the rect that your element is. Basically, x, y, and then x plus width, x comma y plus height, x plus width, comma y plus height becomes your bottom right, bottom left, and top right. Yeah, it calculates these coordinates, and these coordinates it is going to use later to calculate where the focus has to go. Now, let me take you through an example. Okay. So I'm going to press the right button. The focus is going to shift to asset 2. I mean, to the naked eye, it's visible that is going to go here, but what actually happens behind the scenes to calculate this? Now, this library does some certain things, right? When you press the any of the buttons, right, any of the navigation buttons, it will first call its smart navigation function, and the smart navigation function on a very high level will do 3 things. See, it's going to do a lot more things, but on a very high level is going to do 3 things. It will check the direction. In the direction in this case is horizontal. We are not going down vertically. I press the right button. The direction is horizontal. It will get the component from the map. It creates it based on the focus key. So like I said, it's going to create a map of all the elements that you have given to it as the focus, as the focusable element. So it is going to have a mapping of the focus key to the element. So it is going to get the component from the map that it has created, and it is going to loop over all the siblings. And then this is a very important point. Check cutoff coordinates. What do you mean by cutoff coordinates? Let's go to the website again. Now I'll go to asset 1 again. and I'll press the right button, the focus goes to asset 2. Now, what are the cutoff coordinates? See, since I'm pressing the right arrow button, right? So all the elements to the left of asset 1 will not be focusable. That is understandable. So this library, what is going to do is going to take the top left of this asset 1 and the, let's say the bottom left x coordinate of this one, and all the elements which have a x, which have the x coordinates less than this, it's not going to take those elements. Okay, it's going to straight away reject, because we are pressing the right button. It is obvious that all the elements which have the x coordinate greater than this will be eligible for focus, right? So this is one optimization that this library does. Okay, so let's go back to the slide. Yeah, so like I said, it's going to reject the sibling if it does not pass the cutoff coordinate check. And if the sibling is selected, then comes the most important piece of the puzzle, which is sort siblings based on distance, and it takes the first element from the sorted list and shifts the focus. Now, this is the most important point, and we are going to dive deep into this. Yeah, so let me give you another example. So let's say I'm on a set 1. I will press the down arrow button now. You will see that the tile is shifting. Okay, now the tile shifted. Now let's see how did it calculate, right? So an important thing to note here is, it might not make sense immediately, but like I said, it is going to loop over all the siblings of this element. So if you loop over all the siblings of asset 1, see, there are no siblings which are beyond this, right? There are no siblings which are beneath this, is what I mean. All the siblings are to the right of it. So what is it going to do? Now, it is going to run the process in recursion, the library. So it sees that, okay, asset 1 does not have any siblings which are, you press the down arrow button, right? The navigation is vertical. So it is going to see, okay, now there are no elements to down to the, I mean, direct siblings of asset 1 which are beneath it. So it's going to go to the parent element. And remember, like I said, all these elements are wrapped in a parent container. So it is going to go to the parent container. The parent container is this, the outside boundary which is not visible to you. I mean, I'll go to the website to just show you. Sports, movies, and all these tiles are basically the outer containers and siblings to each other, right? So when it determines that, okay, asset 1 does not have a sibling which is down to it, it runs the process recursively. It goes to the parent. Now comes the important part. How does it calculate the I mean, this tile series also has many siblings. How does it calculate which is the closest to it? So it is going to take the bottom left y coordinate. It's going to take the bottom y coordinate of this and top left coordinate of this. See, it is going to take the y coordinate, which is obvious because we are going in the vertical direction. We are not going in the horizontal direction. This is obvious, is going to take the y coordinate. Now the important point, it might be a little tricky to understand initially, but why is it going to take, I mean, this boundary? It could have taken the bottom boundary of this container. See, the logic for this library says, I am always going to take the closest coordinate to the current element. The current element is this. So it is always going to take the closest coordinate. The closest coordinate of this box will always be the top left. It's not going to be the bottom left. It's always going to be the top left. So it's going to calculate the distance between the bottom left of that and the top left of its siblings, and then it's going to sort it based on the distance, and then it consequently picks up the first element, which is which is the first element in the sorted array, and then it shifts the focus, which is exactly what you saw in the example. It went one tile down. Now let's see another example. And it's again the same thing, but I'm just going to reiterate. So I'm on a set 1. I'm going to press the right arrow key. It goes to a set 2. Now again the same thing happened. It goes through the same process. See, now asset 1 has siblings. Now asset 1 has siblings to the right? Again the same concept. It is going to take the two closest coordinates to calculate the distance. It is also, asset 1 had the focus earlier, so it is going to take the top right x coordinate. Why x coordinate? Because we are moving in the horizontal direction. We are not moving in the vertical direction this time. This is the horizontal direction. So it's going to take the x coordinate of the top right of this asset 1, and it is going to take the top left of this asset 2, x coordinates. Why not the top right of asset 2? Because see, the closest coordinate to the top right of that is the top left of asset 2. Okay, so it is going to take those two coordinates, and it is going to do this for all the siblings of asset 1, sort them on the basis of distance, and then take the first element which is in the array, and consequently it shifts the focus to asset 2, which is the first element in the distance array which it creates, right? So this is one example. Now, like I mentioned earlier, parent focus key is important. I'll tell you why that is important now. So I'll go to asset 4, then I'm going to shift the focus down. Now, when I come up, you will notice that the focus is still on a set 4. Okay, it is still on a set 4. I will move to a set 5, go down, and then I'll come up. The focus is again on a set 5 automatically. I don't have to do anything. So this library internally creates a mapping of all the children to its parent focus key, and it will automatically save the last focus child. Okay, it is automatically going to do that. So that is the benefit that you get by wrapping the elements around a parent focus key, so that the library can recognize what element to focus on. Otherwise, you will have to do all the calculations on your own. Another important thing to notice here is, See, I'm going to the third element of the side nav. I will go here and then I'll come back. The focus will go on the first element. So this library also gives you an option to disable that feature, save the last focus child. So for the side nav, I have disabled the save last focus child flag. So the focus always goes to the first element, right? So it is that is one of the reasons why the parent focus key is important. Hmm.
We are saving the state. Okay, this was the last.
The library is focused on state. The library is doing that.
Section 15.
It is going to do that. Yeah.
How white spaces are being entered?
Byte spaces, I mean, this is just the CSS part of it. So it is just, so the map that it creates, the library, it creates a map of just the elements. So it just needs the siblings to that. How does it calculate the sibling? That is also a very important part. So like I told you, it basically associates every element with the parent focus key. Okay. So now it has its own map. So it is going to loop over all the elements and then see, okay, which element has the same focus key as the previous focus element. And then is going to go to the other element, calculate the, again, the distance calculation algorithm kicks in. Right. And then one important thing that I would like to mention, one bug that I faced or one that very important use case which I would like to share is what is the layout changes. What that means is right now you have in sports, if you see, you have asset 1, asset 2. But what if there, just a hypothetical scenario, this will not happen. Let's say there is a polling API running for this style sports and that polling API randomly adds an asset 0 to it. Now see, like I told you, this library does not traverse a DOM tree. You have to tell what elements are focusable. Now you have added an extra element on the page. How will you tell the library that this element is also there and you have to focus it? So the solution to that is there is a function this library exposes which is called as update all layouts. You have to call that manually. That is your responsibility. You have to call that manually. Then the library is going to calculate the map again. I mean, update its map again. Okay. Now, another important use case. What if you don't want the focus to go out of certain areas? Okay. So let's say you have a modal box which has two buttons, accept or ignore. Now, when the focus is on, let's say in the modal box inside one of the buttons, you don't want the focus to go out, right? Because it would look weird. You have the modal box and the focus is somewhere which is beneath the, beneath the modal box or above the beyond box. So you want the focus to be within the modal box. So you can use one flag which the library provides, which is called focus boundary. If you set this flag to true, the focus is going to remain on that within that boundary, which is, and one of the good examples is a modal box. And the last thing is, you might notice here where I'm pressing the up arrow key here, but the focus is not shifting to this element, the element above. The reason being that I've not registered this element as a focusable element. The library is not going to recognize this, so it is not going to focus it. So you will have to register that. So yeah, that was my time. Thanks a lot. Thank you.
Next up, we have Romulo, who is like working in Rippling, and he's going to talk about how did he achieve 60 FPS plus on the scheduling grid. Romulo, if you're here, can you share your screen?
Hey there, can you hear me all right?
Yeah.
Okay, I am a hotel Wi-Fi, so it's not the greatest. Let me share my screen. Can you folks see my screen?
Yes.
Okay, cool. Let me hide my camera. Okay, perfect. Yep. First of all, I just want to take a minute to appreciate all the people that work this crazy time zone difference. US and Bagler office, you folks are the real MVP. That's tough. Okay, for today, I'm going to talk about a case study of an internal project at the Rippling called scheduling, in particular scheduling grids. My name is Romulo. I work at Rippling, as you may know, and I work over time products. Time products are composed of three main apps with time maintenance, time off, and scheduling. And so far, I have been like focusing on time maintenance, even though the scheduling was like under the same umbrella. So a little bit of background for scheduling. It is like a new product at Rippling, and again, like it was born under the umbrella for time products, but was actually like an independent thing for so long. And this project was back in May. So it is the usual thing about the project that's like about to come into beta to customers and validate the features and everything. So it was phase-based development. It's a very complex product, lots of moving parts. It was coming off exploration phase. They're like just tidying up, like the core features. We knew like what we're going to build, what we want to ship, and we know what we're going to do this quarter, what next quarter, etc. But before that, they were like just trying like, what if you do this? What if you do that? Right? That's common on this kind of projects. And one of the things that was like noticeable was that the grid was underperforming, right? Um, and again, I just want to say that this is a case study of this project specifically, but I want to share that it was like a very modern code base, like all the good standards. People are there like are very, very like talented engineer. It just so happens that when you're building things and it just shifts and the requirements change, etc. Sometimes changes happen and some performance regression is the results, right? And then like I was working over time maintenance, as I mentioned, and my manager, the director of the time products, came to me and said like, Romulo, like take it 2-3 weeks and go help the schedule team like sort this out. They are focusing on the business side of things, which makes complete sense, of course, and see like what you can do to improve this. So this like I feel like it's a very interesting project for a talk because I was not part of the team that builds the scheduling project and was not part of the team that builds the scheduling grids, was the core components of this product. So I gather like a few tidbits of like tips, information, etc., tools I use to get to these projects and make like an impact on the performance. So this is like just like a screenshot of the grids. You can see that there's like a list of employees, which is like the roster for the company, and have like the days of week and the events they're associated with them. We're not showing here, but we have like several types of events. There's like a vacation, sick, and like switch shifts to somebody, and they have like conflicting shifts. I mean, I have like few conflict shifts here on the Monday and Sunday, and it's like a red outline, and then the next more like Wednesday, Thursday. But there's like a lot of information, and this grid have like lots of features and different views, such as the same thing, like a weekly view, but instead of like the events take the whole cell, it just takes like the fraction corresponding to the like, time of today. And you can also see some place. This is like a very small, maybe like next, yeah, this one. So you can like also mark we have like a break and a meal break, which is important for a company that's wants to be like compliant to the local regulations. And they also have like other features. You can see like on the 5 p.m. there's like a vertical ruler, which shows what time today. So if you want like a drag and rearrange the grids, like when the thing starts and ends specifically, you have this this little thing here on the screen. That's you can see it because it's static, but also you move the mouse, it also updates like in real time what time it's there. And also you can see like because it's static, but it's very interactive this grid. You can select, you can move, you can drag, you can resize, you can drag to select, you can do all sorts of things you would expect from seeing this on screen, right? So very complex product. And here you can see that's common roster like 40 employees. So lots of information screen, right? At the back in May when inside this part, there was no virtualization of the grids. But so you can imagine like you have bring this data from the server and have to render this all at once. Before the talk, I'm just going to share the results because this talk, even though it's a case study scheduling grids, is relevant to scheduling grids specifically. It's more like a React in general. But just like give it an idea in 2 weeks what we managed to achieve. We selected like a few interactions of the grid, no direct select, direct move, etc. And here's the numbers for like the React comments before and after, and how faster was that, right? So we have like seen things that's like 95%, almost 95% more performant in the sense that less commits on React. But at least the very least at 40, which was scrolling. Again, just like a 2 weeks exercise. If you like spend more time, of course, we could like get better things, but I guess like whatever we got was meaningful. And here, like the frames per second, as I mentioned, is the title of the talk, right? To measure this, I use request animation frame and just like computed the delta from the previous frame. Like people that are familiar with this particular API notice that you get like the timestamp when the frame is being executed. And on the before grids, before any kind of optimization, we had like the majority of the frames would be like between 30 and 6 frames per second. And these like the total frames that was under 6 frames per second. And after optimizations, we got pretty much clean state here. Pretty much like everything was above, at or above 6 frames per second. Okay, and the other thing that we measure is that if we go back a little bit, you can see that like we can change the week, right? The day, the week. And I use this as a measure. So before my work, we are getting about 3.5 seconds to change from week to another. And after my change, we reduce to 650 milliseconds. So about like 18% improvements overall. Oh, I mean like 83% overall, just like the this divided by the last divided by the most, right? So like there's a 10x improvement on rendering time alone, right? And again, React commits, which is part of the performance for the rendering, but just to point out that we reduce the time of commits is about like 1/4 of what it was before. So in my view, it was like a huge achievement for just 2 weeks of work. Okay, so that said, right? We had like this problem. I was like working on time maintenance. My director came to me and asked Romulo, look at this product, see what we can do. The team's like very busy with the business aspect of that, core features, fixing bugs, and etc. 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 So it was like an interesting experience because I didn't build the scheduling. I wasn't part of the scheduling team overall. So like what tools I'm going to use to see areas of might not be performance as well, and what areas I should not like look into, at least at first. So I'm going to I don't have a lot of time here, so I'm just going to do like a laundry list of tools and tips overall, and hopefully that could be like helpful for junior, mid, and even like senior engineers. So the first one that should be like to better for everybody is React Profiler. You open a page and you have the grid there, and then you say like, let's select something, right? So you open the React Profiler, which is like the a tool that built by the React team and is available and hopefully on everybody's browser that use React, right? And do like some operations, records, and stop recording. So this view is going to give a number of comments that React made to make this page happen, to this interaction. Just a reminder, every commit is a set of changes that React decides to apply to the DOM, right? Just a very brief reminder of React is, you have a virtual DOM and have like some mutation that happen, like an event or click or a timeout or etc. And then you're going to apply set mutations to the DOM, right? This operation, very like high level, means a commit on this case. So it's like a set of operations that the React is going to apply to the DOM eventually. So on this view, you can select that on operation was recording here. We have like 25 comments. That's work that React did on my page, right? And the taller the bar is, the more time it took. And also the color is also helpful to have like this visual thing. And each comment, if people are somewhat familiar with in terms of React, means like a frame on the browser, right? Okay. So you get like this comments, and then you start investigating, right? You get the tallest bar there and like see what's happening here and what can I do, right? So on this case, you can see that there's like the virtual DOM snapshots with like the hierarchy of the components, tab errors, base depths, context, etc., etc. And then finally you have the highlighted rows here that are the components that actually render on these comments. So I have tab key, whatever, and took 0.3 milliseconds of 0.9 milliseconds of the total. And this, like, each bar is going to have like the relative time they took based on the parents, which very useful information. So you see like tab key is being re-rendered on this comment. Let's see what's happened. Let's click on that, and it's going to show on the right side that the reason for this component to render on these comments was that the hook won't change it. So this is like kind of useful and not useful at the same time, because, oh, nice, like a hook change, but what hook, right? And also which other comments of this recording session, it also re-render, which can be like very useful information if you want to find like a component that just renders too many times, right? So we got the components type, and the hook won't change it, and it render on the first comments that I highlighted here. If I go to the components tab from the React DevTools, the components already selected, which is very helpful, right? You have several instances on your page. It's helpful to know the right one you're looking at. And here you can see it shows the list of hooks of these components. And the first one is the context, right? So very easy, very clear. And if you go look into how context can change, there's one way for context to change, right? Is the parent component to render and change the value of context. Sometimes not as obvious. Sorry. And sometimes like the props change, but again, like it changed the prop, but doesn't show like the value that was changed, which is information that's helpful, but not as helpful as one might expect. So you click here again, like another example, this time like the side nav change, and you can see like the whole component tree re-render, right? If you had like a memo in some of the children, it would be great if they didn't have to render on these comments. And again, this is very useful information to know, like if you like use memo or just memo for the components, might be helpful to improve the performance. And here it says like hook 36 change, which is as good as nothing, right? Because how can you know which one's 36? So you open like the list of hooks that's also provided on the same view, and you see hook 36. It's a callback, and like callback never tricks the React component, never calls the React component to render. And on this particular case, there's like a bug on the tooling. I don't know if it's React Dev Tools on the implementation of the React itself, but let's try to debug this, right? So hook 36 is a callback. It should not happen. Let's click on this bug button here, and this is going to log all information of these components on the console. So props, hooks, nodes, it's all information here. And I'm ashamed to admit that I only learned this like a couple years ago. I don't know if it was implemented before, but it could be like very useful. Project I had like some years ago. But yeah, congratulations, we have this now. So we have like the list of hooks, and we right click and store as global variable. It's going to be like temp1, temp2, temp3. And then use this function here to fix that list. Turns out there's like this sync external store that's useStance, which is a state library we use at scheduling. It doesn't count. It just like skip this one and makes like the offsets to be wrong. I can share this code later, but it's not like super sophisticated. So we call this function, and now I get the real list of hooks properly enumerated. So in this case, you can see like there's the states that change, and there's like the hook source, etc., and everything else we can like find out by ourselves, right? So this is like the tool that already exists on the React, and as I mentioned, like sometimes they don't have the information, like what the values change to be very useful. And for this, there's like this helper hook. There's like a diamond dozen, just Google that. Use why did my components update, why did you update, why updates. There are like several versions, but basically give like a list of values, and each time the component render, it uses like a use ref to keep the instance reference to the previous values and compare again and print on the console. So one common case is just use why did update with the props. Sometimes it's not as clear, not a prop, as I mentioned, like there's a state change, right? And there's like dependency of the callback or the memo and etc. And sometimes it's not very easy to isolate the values. So you can use like this, use why did updates, and you can base like a oh god, sorry, any kind of like information objects, and it's going to do the comparison for you. And then it's going to console log that the first name changed from John to something else. So with this information, you can try to go backwards and identify where this value changed and why did it cause this re-render. The other tool that's not React, but it's also very helpful if you're using React, is the Performance tab, which comes to the browser, Chrome, Firefox, etc. And again, you click like record button, you do whatever you have to do on the page, and click like stop recording. And on this view, let's say on this specifically, right? I click a button and it fetch like more information, and when the information arrived, it's rendered on the screen, right? This is like a long task. For people that are familiar with how tasks work on the browser, you have like long tasks and have like micro tasks. And the main difference that the long tasks is like on the main thread, right? There's like another subtleties, but enough is enough like information to know that it blocks your main thread, right? If it takes 300 milliseconds to run the long task, it's your browser is going to be blocked by 300 milliseconds. And this performance tab is like very useful. Again, it's a tool that's available everywhere and gives like all the information you want to know about execution of JavaScript, right? So if you click like any of those things, it's going to give you like a breakdown how much time was spent like scripting, rendering, painting, etc. And then like final total time that was for the task or collection of tasks. You can select more than one. If you go to like a bottom up view, is the same information, right? Just like a different way to present that, bottom up in the call tree. But a few events that you should look into when doing this beyond like your own components and helper libraries. For instance, on the scheduling project specifically, we use time zones a lot. And then like early on, we found out that the time zone library was taking like hundreds of milliseconds. We found out that because we switched time zones, it was just like expensive to create information for the time zone, to compute the difference, and we just cache that information and save like a bunch of time, right? So this view is going to give this information, which libraries you use, components, etc. is taking a lot of time for processing and scripting. So in particular, on top of that I just mentioned, you should watch for garbage collector. And on this case, you can see like it takes like 181 milliseconds, which is a lot of time. And also watch for recalculate style. Right? I'm going to talk a little bit more about style further on, but the garbage collector is like the enemy of all dynamic languages. No language that has garbage collector. It's very easy, elegant, comfortable for you to just create like instance of objects and functions and closures and etc. and let the computer fit that up for you. But just a reminder, everything has a cost, right? You should be mindful of create those things if you're like in a hot loop, because the more objects you create, the more the garbage collector you have to work, and the more it's going to block your beautiful application. Here's an example for recalculate style. You see like there's like a rendering tree here, there's like some components, etc. And we need to recalculate style, which is like a blocking operation for 100 milliseconds, right? This is like a huge red flag when you're trying to optimize interface. So look out for that. I'm going to talk a little bit more about this further on. And here you can see like example of components, right? What functions they call and like what's the composition of the time they took from the overall performance, right? On this case, like very simple because I took this shot after the optimizations, so there's not a lot. But on the before my work, this like was a huge list of nested functions and etc. And the employee schedule row is like each row on the on the grids with the columns, right? So it was very important to optimize this. Any questions so far? I know I talk a lot. Those like a base tools, right? You can like just Google, YouTube, etc. how to use those. I just expose because a lot of engineers I found out don't know about those, and they're like very helpful if you want to investigate performance or even like debugging. They're super helpful for that as well, but for performance, like super crucial. No questions? Okay, moving on. This like is just a long list of things. It's not like super structure. It's just like things that help me achieve the numbers I share with you. And maybe like it's helpful for your project, maybe it's not. And as a reminder, this project specifically, it was like a very complex components and a lot of data, and you want to optimize that. Like not all tips I want to say apply to all projects. No, like don't go rewriting all your code to do those things if you don't have to, right? It's completely okay for you to use whatever you're using. If it's just like a simple application, not a lot of interactivity, it's fine, right? But if you want to build the components that's highly interactive, there's a lot of data, keep those in mind. And again, nothing groundbreaking. There's like plenty of articles talking about those, but those specifically helped me on this particular project. The first one's super obvious, but avoid work. The less work you have to do, the less CPU you're going to take, and the faster it's going to be, right? It sounds obvious, but the devil is in the details, right? And the next following points are going to be just like variations of this tip, just specifically on those scenarios, right? On the right side, you can see like a component, a regular component on scheduling, and you can see there's like 73 hooks on this component. And every time a component renders, it has to call all those hooks. Even though you have user memo and you have for by dependencies or like use callback, use memo, you don't have to recompute those things. You have to create a closure for use callback, use memo, and etc. You have to create an arrays if the dependencies of each one of those. You have to compare those dependencies and have like discard the previous iterations. You have to call all the functions to see if you need to update or not. So there's like all work you have to do like every time it renders. Like as much as you use memo and whatever, there's still work you have to do. So if you can avoid doing work, just avoid doing work, right? The more you have to do, the more you stress the garbage collector. And functions surprisingly have runtime costs. They're not free. JavaScript has like functional programming principles, like closures, etc. But it's not a functional programming language, right? Functions are functions on their own thing. The second tip, and this is like I know it's like not great to do on the React meetup, right? But it's completely okay to bypass React, right? React was built for you to have like abstraction over updated UI and give like primitives and a way to do things efficiently. But in the end, it's all DOM, right? You still have like your DOM tree, your DOM elements still have states, your DOM elements still have like attributes you can use. If you do like get bounding client heads, it's still going to work. So use that, right? You don't have to abstract everything to React just to make like the architecture gods happy. Oh, I'm going to abstract all my application. I'm going to think of my application, a stateless machine, etc. Yeah, if you do that, that's great for you. But if you want like to take advantage of the tools and the APIs and everything that's already there, leverage them, right? Be mindful, of course. Don't do for every component, as I mentioned. This is like a particular case where performance matter. But just be mindful that's a tool you can use. It's at your disposal, right? So for instance, direct select. The previous implementation, you would have like each component register themselves on like a global store. And every time you start dragging, you would have to check those things, etc. And again, it's more work you have to do every time a component mounts, right? And re-renders. So I removed that from the components. And now I have like another library that just adds the listeners on the DOM itself and do everything on the DOM, right? It just fires events, custom events, and the React components can listen for those events, right? I have a bunch of custom events, so I just have one entry point, which it's better. But even then, you have to have multiple. It's still like useful. Analogously, deep link, same thing. We had like a store that when we mounted the components, we would register the components and the ref to the elements on those registry. So there's two things. First, you have like a hook that works, that runs every time I mount the components and renders it. And I also have another use ref to keep like more things in memory, stress and DGC to reference them later, right? And again, the elements on screen already, so use that. And they're like hover and before and after, pseudo elements in the content, which like tricks I use. Hover specifically, a few components we use like React, like is hovered, set is hovered, use states, and you don't need that, right? CSS already has hover. Let's leverage that. And before and after content, if you folks remember, on like the ruler and the tooltip on the time, again, like every time you move the mouse on the grids, you'd have like set states and they cause a remainder and I have to cause like all the hooks to run again, and etc. And I don't need that, right? I can just use like like grid backgrounds, elements, dot add event listener and work all the same perfectly. Moving on, another thing that's it is one specifically for this kind of like high density and lots of elements is to not use a list of items. It's very tempting because again, like you have the list of items, you can filter, you can sort, you can do all kind of crazy stuff on those things, and you just pass the list of items to the components like this on the list. But the problem with that is every time you have to change a single element, you have to render the whole list again, and this is a performance killer. As much as you use memo, as much optimization you can do, it's still work you have to do, right? So instead of that, and again, not for everything, for this type of case specifically, I recommend to use like a store where each item subscribe to the store to have like to re-render when the item change, right? There's like implementation I'm dosing. Most, if not all, state management libraries support something like that. So use that. But don't think like you have to rewrite your static like 5 items element to use this because it's just work for nothing. But if you're doing like an UI like this, lots of elements, consider using a store and make the item subscribe to the change for the element itself. It's still okay for the parents to have a list of IDs like sorted and like visible. But for the items, on the scheduling grid's case, like the events, the colored events on the screen, it's much better to do it this way. Another thing is that there was like an article the other day on the Harken News where they like had like, oh, with 10x our performance, and turns out we're using reduce. That was not surprising at all, right? This is the kind of things that you can shoot yourself the foot very, very easy, and it's very common to have this. I'll make a point here that for me, I basically never use reduce unless it's very simple, like the example here, like a simple accumulator. Is usually much more elegant to use a for loop to do those things, right? And here you can see like a very simple benchmark, and this is like kind of stupid, like very simple micro benchmark, but shows like that's things have a cost, right? Reduce, even though it's like super simple function, it's still like 27,000 operations per second. If you use like a for const of, it's 45, but if you use like for var I or let I, is like 178,000 operations per second. So the just-in-time compiler for JavaScript runtime can really optimize these kind of things. Again, it is a micro benchmark for very simple things. On your run-of-the-mill loops, reduce, etc., is not to be like as much, but it's going to be for sure 2-3 times faster than a reduce thing. Again, unless you're doing like those hot loop things, don't bother, but keep that in mind that when you're trying to optimize for those things, reduce is usually a culprit. You shave like hundreds of milliseconds rewriting reduce to use for loops on these projects. Another example here, and this for the love of all secrets, never do this. Reduce and you return like the spread objects inside the body of reduce. This completely obliterates the garbage collector. Again, the article from Hacker News was about this, right? I should have linked it here. Sorry about that, but anyway, it's not secret. Everybody, most people have a stumble on this like sometime or another, but please be mindful, don't do this. It's completely fine for you to mutate the accumulator inside the function here if you're going for immutability. As long as you don't mutate like arguments or global variables, you're fine. So this like kills your performance, right? You can see like there's 3.8 thousandths per second. And this is like an M3 laptop, right? And not like on the Raspberry Pi doing these benchmarks. So this is like a top of line MacBook. And you can see like the other loops have like a much better, like 10x performance on this, right? As a corollary of that, the rest of like the function programming principles, like map, filter, etc., they're usually 3 times lower than a for loop for the same benefits, right? Function calls have costs. Every time you call on those things, they create like intermediate array, and that creates like stress to GC. And those things also can't use a continue or break. And sometimes you just want to operate like a few of those items and have to run through all the items, right? Whereas on for loop, you can like use continue and break. The JavaScript runtimes optimize for loops much better than optimize callbacks closures. And also be aware that for const stuff, there's like a runtime cost because of how iterators work. People see this and things analogous of a for I loop, and it's not, right? If you check like the Babel outputs for compatibility, you can see like they do a lot of code to make for const off work. Just be aware of that, right? Most of the time it's fine, but if you're pushing for performance, keep that in mind. Another advice is just pre-allocating arrays whenever possible. Every time you have to push the existing array, and the array has to grow. People, computer science, you remember you have to create a new object, copy objects over, or do like other kind of like smart things, but it's still work you have to do. So avoid work. If you know the number of list items you need, just pre-allocate that. If you don't know, you have a good estimate for more, because even then it's much better than keep changing the size of the array. This is like the topic that I mentioned before, layout effects block the main threads. React abstracts much of this for us, if you're using React, obviously. So you don't have to worry about this as much, but back in the day, this would be like a one, always like on the top 10 list of things to optimize for performance. It's just every time you query the layout properties of the elements, the browser has to run the layout, and it's a blocking thing, and it's very slow, super slow. So avoid doing that as much. On the previous talk, I found that very interesting. Like they have like to calculate the layout of each button, so you can like just walk through those things. So just mentioning that, and if you can like cache those layouts and do your operations over those cache values and it's not stale, etc., go for it, right? So you don't block the main threads for the browser running layouts, and everything is happy. Everybody's happy, right? And use layout effect for that matter. Try to not use. Have a good reason to use that because it could cause the layout to change. So be mindful of those things. And that's it. That's like my main tips. Hopefully you guys found like something useful, and I open to questions.
Any questions? No, that was all. Thank you, Romulo, so much.
Thank you all. Have a good day.
Yeah, bye.
Bye.
So now for the next talk, we have Manish, who is going to talk about storing large data set in ES6 and allowing GC to kick in easily. Please give a huge round of applause for him.
It'll be too late for me.
Whatever works for you.
So, what will be the total? 15 minutes, probably. I'll ask them. Let me ask. Hey, hi guys. I know we are reaching at the end of the session and almost everyone's battery is pretty much dead. I can clearly see it, including myself. Right. So, but I'm going to make it for 15 minutes, guys. So, I have a two topic. One, what you see in the official agenda page, right? That how do we use GC and create those kind of optimization for one of my project statement.
The second one, which I really want to talk about is the finance for IT folks in general, right? How does the finance has actually worked for a lot of folks, right? And what do we do to keep our inventory of finance running, right? So you guys will have to help me. Tell me which topic do you want me to hear for next 15 minutes? Right, is that, okay, let me put it. One is a tech topic of GC for my project specific requirement. The second one is a finance. So all those who want to hear for a week, a GC one, can you please raise your hand? Okay. And, okay, and for the other, the finance part of it? Okay, okay. So I see the other story has goofed up. So guys, since I promise you, I'll take the tech part of it at next meetup. But for now, right, I'm going to keep my scope of my talk, right, for the next 15 minutes to make you understand that how does the IT has actually worked for us. By the way, I'm sure a lot of you probably would have seen me talking about it or in other stage or other forum, but I cannot keep going away from this because this is something which is very core to my heart. And since we guys have spent 15 plus in the tech and we see the next Gen Z, right? How does that coming up? So that is what something I want you to take it. It's just a thought process, guys. I cannot change anything in the next 15 minutes. I can just put the ignition in your mind that what is IT all about, right? So I'm going to quickly share some of the slide. Okay, so it start with GC and all, but I'm not going to take that. Is that okay? So, oh, why it is not? Okay, I'll skip the title and all. Every title will come back in the next meetup. Skip this. Okay, this is just about me. Who am I professionally? I'm just a pure developer, as you guys, pretty much old, but now, but 14 years all into a tech, pure code, nothing else in my life. Zero management, zero team leadership. I don't believe in this. Okay, I have spoken. I have been pretty much all into a code. I started my career as a BlackBerry developer. Okay, moved with Samsung into the browser, e-commerce, and XYZ. Right, coded across a domain. None of them. I do not hold specialization in any of the domain, guys. I'm just learning the way you guys are learning. But I also understood during my journey that I know nothing, for sure, right? So this is who am I, right? And pretty much, okay, right? My 10 years has gone with one company, Samsung, and currently with the Walmart. Okay, so this I'll skip. Yeah, this is something which I want to do it, guys. This is one of the thing which I do it highly for corporate freshers. Okay, I also do it for colleges. Okay, a lot of people may disagree. Feel free to pitch in, guys. Feel free to disagree. You have all the rights to prove me wrong, but I'll be more than happy if you prove me wrong. Okay, now, how does IT has worked, right? This is something which I have learned it in my career, and probably since I'm coming closer to my 40s, right? I realized that if I knew these things in my 20s, probably life would have been slightly easy for me, or would have been slightly more informed, is what I'm saying it all. Right. So the first thing, just pretty easy. I know you know everything. You guys will know what I'm going to say, but still I'm going to put it again back in your mind. This is the first one is own your career, guys. IT. See, we as a workforce work for a corporate, right? Corporate gives you a compensatory compensation. They call it compensatory. Do you understand what does compensatory means? It means I'm compensating you for your time and the talent that you bring in on the table. That's it. There's no other business. We are not your family, now we are neither you belong to any of us. The moment you put your paper, you and from the next day, nobody knows you in the world. Fact, you will have to acknowledge this. Loyalty and all works well to some time as long as you have a relationship with your teams. The moment that relationship goes out, from the next day, you are also out. Acknowledge this fact. So own your career. When I say own your career, it means decide what you want to do it. Corporate, how does a corporate works? We get you the project. We put you into the team, you start coding it. Initially, you start with your own module, build it, put it on the prod and do XYZ, right? That's how and the company make money by getting those releases in the cycle, right? So, but the companies will give you all the projects, or your manager typically will give you all the projects through which company make money. Even though, believe me guys, since I have been into the leadership role for some time, even though we tell you that we align with your career goals and all, but all are crap. Okay, none of them. I mean, that's how your business works. You can't change it. Business have taught us. We have become highly corrupted. Some people will acknowledge, most of them don't. They don't have the guts. But I really don't bother because that's not my nature. And a lot of folks like us doesn't bother. Right. So own your career, decide what you want to do it. How do you want to take it, guys? It's okay to make mistakes. Learn it, reiterate. That's how we are doing it. Decide what do you want to do it. Do not go with the flow of your current project. If you like it, well and good. If you like your manager, well and good. But if you see there is something which I want to change it, apart from you, nobody else will help you guys. That's a fact. Manager does not help, company does not help until you really help yourself. So know these facts. Own your career. In my case, if you ask me, I made a lot of, in my 10 years of corporate career in Samsung, I have changed 10 different teams. Okay, if one of the project does not work for me, I go ahead and change. Some people did not like it, but it's okay. It doesn't matter. As long as I learned and I made money in the process, I was okay. Right? So own your career, decide what do you want to do it. Okay, nobody else will help you. Value your time, guys. A harsh truth of IT, we guys are not something who are there in IT for next 30, 40 years, all that. That generation is gone. Typically, the lifespan that I see on the forum, on the floor, is typically 18 to 20 years. Harsh reality, but that's how. After 18 to 20, we all find it difficult to sustain in India. That's a fact. In US, I will exclude, US have a different working environment where you can still code by 25 plus. India doesn't happen. India relies on a cost factor. That's how the game works. So 18 to 20 is what the time that I'm seeing it. The good time. I'm sure a lot of us want to continue till 30 years. And a lot of people have continued it. But I'm not seeing that on ground that current generation is able to do that. That is where my problem begins. And a lot of people don't even realize this. And by the time they realize it, they always find they are every single day become very struggling. Right? We all want to make work as a fun, guys, right? Work is not just about just working it. Every single day when I wake up, I give my life to my work, right? You are spending your day. So the work has to be exciting. If it is just struggling, till how long will you be able to do it? Right? So think about it, that value your time, play your finance, right? In a way such that within 18 to 20 years, you all guys will come into the financial independence wala story, right? Value money that I have told you. A typical, what kind of people do I see on ground? The people who actually invest, right? They keep investing. But the people who don't invest, they never invest. That is how I'm seeing it on ground. And that's a change you need. That if somebody who's not investing, just to give you some simple calculation, guys, if 55K per month, right, for just 16 years can get you 2 CR. So somebody at a 16, 17 years experience guy tell me that I do not have a 2 CR, I do not buy that opinion. Right? So we guys make far more money compared to other folks, other industries. So you will have to play your cards with that extra money. If I just divide your anybody's expenses, it's just 30% in your needs and 70% is what typically you will be able to save it if you're smart enough. And I'll give you one mindset, guys, which a lot of my friends are doing it currently. They say that from the day one, we have learned, if I get say 100 rupees, I make sure that my all needs, right, are being met with 30 rupees. 70% goes into the investment, which creates pipeline for me, which makes money for me. And all my desire part, if I want to buy something which is non-essential, I do it from the money that I get it from my invested amount. Think about it. Never, ever invest your principal corpus in buying the desire part of your life. If you want to buy an iPhone, do it when you actually make money from that invested amount. And believe me, by doing this simple strategy, you will never run out of your life from money. You will always have money. The mistake that people are making currently is they are actually using their corpus, guys. The initial corpus for buying a desire. That's where we are failing terribly bad. And everybody is playing the game on it. The whole calculation on e-commerce, if you see, is not about total price. It's about EMI price. That clearly tells where we are heading to. Right? So change your mindset, your money that you make from your job, right? Divide that into parts and use that part for your survival. And rest all should go on your investing, guys. And whatever money that you make from investing, choose your desire. I'm not saying that you will have to get away from desire and the fishes. Hey, we are humans here. I'm here to live my life. I have to live, right? That is what's the point. But if you have to live your life, you will have to know whether you really can you afford it or not. right? So think about it when you go home and all, right? Think about it that am I spending my real money that you get it after paying 30% tax, right? Am I spending on my need or is it on my desire? If you're investing on desire, spending on desire, take a back step, guys. Highly need. This generation needs far more these steps just because our jobs have become far more unstable. And it will, guys. Workforce optimization has been the core principle through which every workforce works historically. So workforce will optimize. You need less workforce, right? And machines will do more work. You accept it. That's how the industry will go. So jobs will come down. It's just that we are facing that torture because India have a huge surplus of labor, right? So play your finance cards, save, right? EPF. There are a lot of great investment, guys. If you ask about me, a lot of people will tell you that do not invest in, what do you call? In the public PPF, public provident fund. Believe me, guys, they tell you that 7.5% the interest that you get is very less, but the mindset that it brings is simply amazing, guys. Okay, you're just investing every single year 1.5 lakhs. Okay, 22.5 lakhs in the 15 years, get you a corpus of 40 plus lakh. It's not bad. The mindset that it brings, right? That every single month I will have to save. It changes, guys. And believe me, once you get into that zone, you are always into the zone. You will have to do it. And we have no choice, guys. We are into, if you do not have any inherited wealth, we will have to do it. If you have inherited wealth, the equation changes drastically, which I'm not going to count. But if you are just relying on your income salary, right, to make money and to live all your life, you will have to do that. I know it may be harsh and all. Anybody who want to pitch in, saying that this is something which I am doing or I am not doing. Are you guys, okay, tell me guys, out of 100 rupees that you make per month from your salary, do you invest 50? How many of you invest 50, more than 50% in purely in investments? Raise your hands, guys. I see 1, 2, 3, 4, that's 5, 6, right? None of right? That's clearly this sampling shows you where are we heading, guys? Think about it. IT has become a mess. Okay, the people who made money, the real golden minds were the guys who joined IT in early 2000 or the late 90s. They are the real champions. We are not. And I'm seeing it on ground. But we make money. Don't we make money? We make a lot of money, guys. Believe me, the moment you have a skill set, we make a lot of money. For us, into 2, into 4, all these calculations, we have done it in the past. So your equation to make money double happens in IT. You can't deny the fact. Right, but how do you use it? If you start inflating your lifestyle, everything is in collapse then. What is the point of making money? Right, so think about it, especially for these youngsters and all. Right, and this is something which is very close to my heart. Value your parents, guys, your close one. We all work for them, yeah. We all work for our siblings, our kids, our parents. Right, why we trouble them only? Right, to who we are working? Are we working for ourselves? We work for others to fill their needs. Respect them, guys. That is what today's generation is highly missing, and it just breaks me, if you ask. Respect your parents. They are the one who have done a lot of things in your life when none of us were capable enough to do anything in our life. Respect them, guys. Right. So I know a lot of us will do it, but keep in your mind that when your tone become rough with your parents, keep them, guys. We have no rights to do that. We are nowhere. If you believe me, if you see, right, I read a lot about psychology of human minds. Okay, I don't know how I got that interest and all, but I read how human mind actually works. And what I realize that every relation that you do in typically human to human, right? Your colleague, your wife, no, not wife, only your colleague or your friends. Everything is highly transactional. You make a transaction. If I'm here, if I'm talking with you, most likely I need something from you. Maybe a referral, maybe anything. Typically, but the only non-transactional relationship is your parents or your loved ones who literally love you from the core. So respect them. Right? Think about it, guys, when you go. And this is something which I see very happening. Burnout is very real, yeah. You can't deny the fact that IT, we guys will have to work 16, 17 hours. A lot of us have worked, right? But for first 5 years, yes, you should. I align with Mr. Murthy concept of saying that for initial years, you should work, guys. You should work. Then only you actually feel that what it takes to make money. But yes, as and when we age, your working hours will gradually decrease, guys. But first 5 years, yes. Do that. Right? If you're not working, if you're thinking I'm having a damn comfortable life, believe me, you will be in trouble in your 6th and 7th year. Life become far more difficult. If I just divide the whole tenure of IT, right? 5, 10, 15. Typically, I end up taking 15 years. 5 years, initial 5 years, you will always have to struggle. Learn, learn, learn. Break the people, break the tech. Learn it by hook or by crook. It will always pay you. Does not matter whether it is aligned with your tech or not, as long as you're in software, right? What I realize is everything will connect, guys. Does not matter whether it's front end, back end, Docker, Kubernetes, AI, ML, everything connects. And if you ask me now at this point in my life when I'm actually work as an architect, I realize that people question me for everything where I do not work on. Okay, they do not question me what I really know, but they question me on all unknowns. That's how I realize key. And for these things, meetup and all are really great place to be. Where you go to all the meetups where you do not work on, understand that what really, and believe me, at some point you will it will start giving you the connection between the dots. You will start understanding it. We all have done it. Use this, especially in Bangalore and all there, when every meetup is free and all, you get good snacks and food. Use that, guys, which you are already using it, but tell it to your friends. It's important. Okay. And right. Anything else? Okay. This is something which I see, guys, which you are all aware, but realize, right? This is not a generation where it's important to be hero. It's not important to be hero. It's really important to be simple. Simple people are the real kicker. The guys who come onto the stage, we are not the real kicker. There are a lot of people who do a lot of work with a lot of simplicity, but they never talk about it. So a lot of people take it as a dump or take it for granted, but they are 100 times better. Respect them. Surround yourself with the people who are smarter than you guys. This is what I have learned, if you ask me, right? I have always surrounded myself with people who are smarter than me. Maybe in terms of brain, IQ, or maybe in terms of EQ, but they're far smarter than me. Do not, if you see that somebody with whom you are having a friend. So who are your friends? Typically your friends are your reflection, guys, nothing else. They are what you want to be or what you are. Believe me, okay? There's nothing called Baki or Gyan and all. It's just reflection of us. So make sure your reflection of us is a better version of us. Okay, and believe me, guys, more than machines, right? You'll always learn from the people. So spend quality time. Be with. If you feel that being with this guy takes away my energy, get off silently without hurting him. But get off. We'll have to do it. One of my mentor, he used to tell me that Manish, you have two kind of people in IT. I said, who all? He said the one who takes away your energy, the second one who gives you the energy. So always, if you want to be successful in your life, be with the people with whom you get the energy, who give you the kick. Right? No need of toxic people and all, but do not try to offend anyone. The only point I am saying is, be with the people who are smarter than you. If suppose, for example, you want to get into IT where you want to do very strong developer, right? Be with the people who are far smarter than us in terms of code, in terms of their check-ins, what they do, right? And in terms of your communication, everything. And believe me, guys, the moment you do it, you may feel slightly awkward in that community, but you spend just 6 months and believe me, you will become one of them for sure. I have seen this, guys. I've seen in my friend circle, if you ask me, I mean, I'm the most Dumbo, to be very frank. Okay. I haven't seen guys who have a slighter IQ than me in my corporate world. So in that way, and the moment I see with that guy who is far lesser than me, I move away very politely. And it helps you guys. It may hurt him or you, but in long term, it always pays you off. Right. So that's the only thing, guys, which I wanted to highlight. So investment is which you should take away from here. Think about it. How do you create a pipeline? Guys, believe me, everyone at the top leaders have made huge amount of money in IT. They do not need to work, but they're still working just to create another pipeline. They are very smart. Why we are not getting the smartness? Right? Everyone have created a pipeline. I have seen my friends who make 2 lakh per month without doing anything here. Nothing. They don't need a job. But when I talk with young guys, I realize somebody is making 1 lakh and he tells me, I stay in a flat which costs me 45K. I mean, I do not buy that opinion. When you just make 1 lakh, you have by all calculation, 45K in rent does not work out. Right? So think about it, guys. It's a need of the hour. Create a side hustle or a passive source of income. Think about it. How do you make money? How money generates another money for you? And believe me, once you're in that pipeline, it will always help you guys. For me, it took me 5 years. Right? It started from the story of my friend told me that, Manish, if I kick you off from your job, what you are caliber of, what you are capable of. I said, nothing here. I know nothing apart from IT, right? He tell me, can you do something which makes you 5K? I said, I do not know cook. I can't drive in Bangalore. I cannot take parcel. What can I do here? I really know nothing. And that took me 5 years, guys, to create a pipeline of just having a 5K per month in my own structure way. So think about it, right? How do we make money? Whether stocks works, whether investing in the business works, right? Think about it. It takes time, but believe me, guys, once you are into that zone, na, it always helps, right? So that's all, guys, from my side. Any questions for me? Feel free to ask it. Right? It's a very distressing talk, which I do a lot of times. A lot of faces goes dull. Okay. But the fact of the life is you will have to accept it. A lot of people will not tell you. Okay, people are scared, guys. We all are scared of job. A lot of people do not have the guts. Okay, but today's generation, I see they have a lot of guts. That's the reason I turned up. I learned from them that this is how you have to be. You don't have to be so much afraid of a job and all the time, right? Be real, be what you are, and believe me, you'll always have a successful and a good life. Right? That's it, guys. Thank you.
So yeah, I think it's already almost 7, right? So it's supposed to be end at 6 o'clock, and we are late. Yeah, but anyway, I think I hope you all enjoyed the talks. Yeah, we have a lot of good talks, and I hope you all enjoyed the talks. And thanks to all the speakers for sharing your insights, and thanks to Rippling and Sweta for taking care of all the logistics. And yeah, that's all from our side. We'll meet again next month. See you again. Thank you. So we host these meetups every month. So we'll be having one again in October. So see you again then.